You might think the ground beneath you is solid, unmoving, dependable. You might believe that when you sit still, you are truly at rest, but the universe keeps secrets about motion that would surprise you. For thousands of years, humans assumed the Earth was the center of everything, with the heavens rotating around us in perfect circles. Then we learned we orbit the sun. Then we discovered the sun itself moves through space. Each revelation showed us that what feels motionless is actually racing through the cosmos at incredible speeds. Reality isn't as simple as it appears, and scientists continue to be amazed by discoveries that overturn what seemed certain. The stillness you feel right now is an illusion created by shared motion on a scale so vast it becomes invisible to your senses. We'll explore this hidden dance of the universe in this video and discover just how much is moving while you rest. If you like these videos, I would appreciate if you clicked like or subscribed, as it's important for the channel and it helps others find it too, just like you did. Thank you. Now, let's get started. Picture yourself right now, wherever you are in this moment. Your body feels still, settled, maybe even sinking slightly into whatever surface supports you. But here's something that might surprise you. You're actually traveling through space at incredible speeds, participating in a cosmic dance that's been choreographed by gravity and time itself. Right beneath your feet, the Earth spins like a giant top, rotating once every 24 hours. This rotation happens so smoothly that you never feel it, but it's carrying you along at roughly 1,000 miles per hour if you're sitting near the equator. Meanwhile, our entire planet orbits the sun at about 67,000 miles per hour, tracing that familiar elliptical path we complete once each year. But the movement doesn't stop there. Our sun, that seemingly fixed point of light and warmth, is itself wandering through space. It carries our whole solar system along with it, like a parent leading a group of children through a vast, dark playground. The sun travels at roughly 500,000 miles per hour as it orbits the center of our galaxy, the Milky Way. Think about that for a moment. Everything you've ever known, every place you've ever been, every person you've ever met, has been riding along on this cosmic carousel, spinning around a point so distant that light itself takes 26,000 years to travel there. We call this central region Sagittarius A star, and it contains a supermassive black hole with a mass millions of times greater than our sun. At our current pace, it takes our solar system about 230 million years to complete just one lap around the galaxy. Scientists call this span of time a galactic year. Since Earth formed, we've only completed about 20 of these enormous orbits. The entire age of dinosaurs, from their rise to their extinction, happened during just one galactic year. As we travel this immense circular path, we occasionally pass through the galaxy's spiral arms, those graceful curved structures you see in photographs of distant galaxies. These regions contain denser collections of stars, along with the gas and dust clouds where new stars are born. When our solar system drifts through these areas, the cosmic environment around us changes subtly, possibly affecting things like the number of comets that wander inward from the outer edges of our solar system. Now, here's where things get even more interesting. Our entire galaxy, this collection of hundreds of billions of stars, is also moving through space. The Milky Way belongs to what astronomers call the local group, a small cosmic neighborhood containing more than 50 galaxies. Most of these are small, faint collections of stars, but two galaxies dominate this region, ours and the great Andromeda galaxy. Andromeda sits about 2.5 million light-years away from us, but that distance is slowly shrinking. Both galaxies are drifting toward each other at roughly 62 miles per second. That might sound fast, but across such enormous distances, it means these two island universes won't actually collide for about 4 billion years. It's fascinating to imagine that collision, though it's more accurate to think of it as a merger. When it happens, the sun will be noticeably older and brighter. Earth's continents will have shifted into completely new arrangements. Human civilization, if it still exists, will be unimaginably different from what we know today. Yet this galactic encounter has been scheduled by gravity and physics since long before our planet even formed. But even our local group of galaxies isn't standing still in the cosmic ocean. It's part of an even larger structure called the Virgo supercluster, a vast collection of thousands of galaxies spread across more than 100 million light-years. Picture a three-dimensional spiderweb made of light and gravity, with galaxies strung along the filaments and enormous voids of nearly empty space between them. On this scale, our Milky Way becomes just one small knot of light on one thread of this cosmic web. The local group, our entire galactic neighborhood, is slowly falling toward the gravitational center of the Virgo supercluster, adding yet another layer to our complex journey through space. Recent discoveries have revealed that we're part of an even larger motion. Our local group, along with thousands of other galaxies, is streaming towards something called the Great Atra, a gravitational anomaly located roughly 150 million light-years away. This massive concentration of matter pulls on our local region of space, adding another vector to our already complex path through the universe. But there's more. Beyond even the Great Attractor, astronomers have identified an even more distant and massive structure called the Shapley supercluster. This enormous collection of galaxy clusters may be influencing our motion on the largest scales imaginable, pulling our local group along with countless other galaxies toward a region of space so far away that its light has been traveling toward us for billions of years. What's remarkable about all this motion is how layered and interconnected it is. We're spinning with Earth, orbiting with the solar system, rotating with the galaxy, falling with the local group, streaming with the local supercluster, all simultaneously. Each movement happens on a different timescale, from hours to billions of years, creating a symphony of motion that plays out across the entire observable universe. There's something deeply humbling about this perspective. Every human concern, every daily worry, every moment of joy or sadness happens while we're passengers on this incredible cosmic journey. We're not separate from the universe looking in. We're part of it, embedded within layer after layer of structure and motion that connects us to the largest scales of existence. The ancient philosophers wondered about our place in the cosmos, but they could never have imagined this reality. We're not sitting at the center of a fixed, unchanging universe. Instead, we're riding on a small, rocky planet, orbiting an ordinary star, in the outer regions of a typical spiral galaxy. That's part of a modest galaxy group, falling through a vast web of structure that extends as far as our telescopes can see. This knowledge changes nothing about your daily experience, yet it changes everything about how you might choose to see yourself in relation to the cosmos. Right now, as you listen to these words, you're traveling through space at speeds that would have seemed impossible to our ancestors, participating in movements that began long before Earth existed and will continue long after our sun burns out. When we peer into the night sky, our galaxy appears still and eternal, but it's actually racing through space at incredible speeds. The Milky Way carries us along on a journey that spans millions of years, moving in directions we're only beginning to understand. Picture our galaxy as a massive spiral of stars, gas, and dust, all bound together by gravity's invisible hand. This entire structure, containing hundreds of billions of stars, including our own sun, moves through space like a ship sailing through an ocean we cannot see. We feel no motion because we travel with it. The way passengers on a smooth flight feel stationary, even while hurtling through the sky. Our galaxy doesn't wander aimlessly through the void. Something out there, something massive and mysterious, seems to be pulling on us. Astronomers call this Great Attractor, though that name might be misleading. It's not a single giant object you could spot with the telescope. Instead, it appears to be a region where matter has concentrated, creating a gravitational well so deep that entire galaxies get drawn toward it. Think of it like water flowing down a drain, except the drain is made of invisible matter, and the water is made of stars and planets. Our entire local group of galaxies appears to be drifting in this direction, as if we're all caught in the same cosmic current. The force is gentle but persistent, operating over distances so vast that our minds struggle to comprehend them. What makes this even more intriguing is that much of what's pulling us remains hidden. The Great Attractor lies behind the dense plane of our own galaxy, obscured by clouds of dust and gas. It's like trying to see what's behind a thick forest while standing among the trees. We know something significant is there, because we can feel its gravitational influence, but its true nature stays shrouded in mystery. Dark matter plays a crucial role in this cosmic choreography. This invisible substance doesn't emit light, doesn't interact with ordinary matter in ways we can easily detect, yet it outweighs all the visible matter in the universe by a factor of 5 to 1. It's the silent architect of cosmic structure, creating the framework upon which galaxies form and move. You can think of dark matter as the invisible scaffolding of reality. Just as buildings need hidden supports, the universe needs this unseen matter to hold itself together. It affects how galaxies rotate, keeps galaxy clusters from flying apart, and creates the pathways along which normal matter flows. When we say the Milky Way is moving toward the Great Attractor, we're really describing how our galaxy follows tracks laid down by dark matter billions of years ago. The motion itself is surprisingly complex. Our solar system orbits the galactic center, completing one revolution every 250 million years. Meanwhile, the entire galaxy rotates like a cosmic pinwheel. But rotation isn't the only motion at play. The whole galaxy also travels through space, following gravitational currents we're still mapping. These movements happen on scales that dwarf human experience. If you could somehow mark our galaxy's position in space and return after 1 million years, you'd find it had traveled roughly 4.5 billion miles. That's the distance light covers in about 8 hours. Yet for a galaxy, it represents just a small step on an endless journey. There's something almost meditative about contemplating these vast motions. While we worry about daily concerns, plan for next week, or remember last year, our galaxy serenely continues its ancient migration. Stars are born and die, planets form and crumble, but the galaxy's journey persists across timescales that make human history seem like a brief flicker. The expansion of the universe adds another layer to this story. Space itself grows larger over time, stretching the distances between galaxy clusters. This means that on the largest scales, most galaxies appear to be moving away from us, not because they're flying through space, but because the space between us keeps expanding. It's similar to drawing dots on a balloon and then inflating it. The dots don't move across the balloon's surface, but they get farther apart as the balloon expands. In the same way, galaxy clusters separate as the universe grows, though gravity can still pull nearby galaxies together within local regions. This expansion creates an interesting paradox. While our galaxy moves toward the Great Attractor itself is being carried away by cosmic expansion. It's like walking forward on a moving sidewalk that's also being stretched longer. You make progress relative to your immediate surroundings, but your destination keeps receding on larger scales. The interplay between gravity and expansion shapes the universe's overall architecture. In dense regions where matter clusters together, gravity wins, and structures like galaxies and galaxy clusters form. In the vast spaces between these clusters, expansion dominates, and the emptiness grows ever emptier. Our galaxy exists in one of these gravitationally bound regions, a cosmic neighborhood where local attractions override the universe's general expansion. The Andromeda Galaxy, our nearest large neighbor, actually moves toward us rather than away, pulled by the same local gravitational environment that influences our motion toward the Great Attractor. Scientists estimate that in about 4.5 billion years, the Milky Way and Andromeda will collide and merge. Andromeda will collide and merge. This sounds catastrophic, but it's actually a slow, graceful dance played out over hundreds of millions of years. Stars rarely collide directly because the distances between them are so enormous. Instead, the galaxies will swirl together, creating new stellar formations and reshaping both spiral structures into something entirely different. Even after this merger, the combined galaxy will continue its journey toward the Great Attractor, carrying whatever remains of our solar system along for the ride. The Sun will have long since evolved into a red giant, and then a white dwarf by that time. But the gravitational currents that guide galactic motion will persist. These cosmic movements remind us that nothing in the universe truly stands still. Motion is fundamental to existence. From the quantum fluctuations of subatomic particles to the grand migrations of galaxy clusters, we live within nested layers of movement, each operating on its own timescale, each contributing to the ongoing evolution of cosmic structure. Perhaps there's comfort in recognizing our place within these vast flows. We participate in something much larger than our individual lives, something that connects us to the deepest patterns of space and time. Our atoms formed in ancient stars. Our planet orbits a star that orbits a galaxy, and our galaxy follows currents established when the universe was young. The Great Attractor remains one of astronomy's fascinating mysteries, a reminder that the universe still holds secrets we're working to uncover. As our instruments improve and our understanding deepens, we may eventually map the dark matter structures that guide our galaxy's path, revealing the hidden landscape through which we travel. For now, though, we can simply appreciate the elegant complexity of cosmic motion, the way gravity and expansion, visible and invisible matter, all work together to create the dynamic universe we call home. When you glance up at the night sky, something remarkable happens in your mind. The stars appear to be frozen in their places, like tiny diamonds scattered across black velvet. This sense of stillness feels so natural, so obvious, that we rarely question it. Yet this impression reveals something fascinating about how our brains work, and how we make sense of the world around us. The universe we see is actually moving in ways that would make your head spin, if only we could perceive them properly. Every single point of light up there is racing through space at speeds that dwarf anything we experience down here on Earth. But here's the thing, motion becomes invisible when everything shares it together. Right now, as you listen to this, you're spinning. The ground beneath your feet is rotating at about 1,000 miles per hour, assuming you're somewhere near the equator. That's faster than the speed of sound, yet you feel perfectly still because your coffee cup is spinning with you, your house is spinning with you, even the air in your lungs is spinning with you. This shared motion creates a kind of cosmic conspiracy. Everything moves together, so nothing appears to move at all. It's like being inside a train with no windows, cruising smoothly down the tracks. Without external reference points, you might as well be sitting in your living room. But Earth's rotation is just the beginning of our journey through space. Our entire planet is also orbiting the Sun, sweeping through space at roughly 67,000 miles per hour. Again, we feel nothing because our atmosphere, our oceans, and everything else we know is traveling along for the same ride. The Sun itself, which seems like the ultimate fixed point in our sky, is actually falling in a giant circle around the center of our galaxy. This orbit is so enormous that it takes over 200 million years to complete just once. The last time our solar system was in this same cosmic neighborhood, dinosaurs hadn't even appeared yet on Earth. Think about that for a moment. The ground you're standing on has traveled trillions of miles through space since complex life first began. We've sailed past countless other star systems, witnessed the birth and death of distant suns, all while barely noticing the journey. This galactic orbit reveals something profound about time itself. We think in terms of days, years, maybe decades if we're planning ahead. But the universe operates on scales that make human history look like a single heartbeat. Mountains rise and fall, species evolve and go extinct. Entire civilizations could rise and crumble, all within just a small fraction of our galaxy's rotation. The Milky Way spins like a vast flattened whirlpool, with spiral arms sweeping outward from a bright central bulge. These arms aren't solid, like the spokes of a wheel. They're more like traffic jams in space, regions where stars and gas clouds tend to bunch up as they orbit. We happen to live in one of these arms, surrounded by the stellar equivalent of rush hour traffic. But even our entire galaxy is in motion, drifting through space toward a collision with our nearest large neighbor, the Andromeda Galaxy. Don't worry though, This cosmic fender bender won't happen for about 4 billion years. When it does occur, the distances between stars are so vast that very few actual collisions will take place. It'll be more like two ghost armies passing through each other. The strangest part of all this motion might be how it affects our sense of home. We think of Earth as our fixed address in the universe, but really we're passengers on a cosmic ship that never stops moving. Every breath you take happens in a slightly different location than the previous one. You'll never return to the exact same spot in space, twice. This constant motion raises curious questions about what it means for something to be in a place. If everything is always moving relative to everything else, then maybe location itself is just a temporary agreement between objects to travel together for a while. Ancient astronomers called the stars fixed because they seem to maintain their patterns night after night, year after year. They weren't wrong exactly, just limited by the scale of human perception. The stars do keep their relative positions, but only because they're all swimming in the same galactic current. Over very long periods, even these familiar patterns slowly change. The Big Dipper looked different when the pyramids were built, and it will look different again when our descendants gaze up at the sky thousands of years from now. The stars themselves are aging, evolving, sometimes exploding or fading away entirely. All of this motion, from Earth's spin to our galaxy's drift through space, happens within an even larger context. The entire universe is expanding, carrying distant galaxies away from us at ever-increasing speeds. Space itself is growing, like a balloon being inflated, with galaxies riding along on its surface. This expansion means that the most distant objects we can see are racing away from us faster than light itself. Their light left them billions of years ago, when the universe was younger and smaller. We're seeing these ancient galaxies as they were, not as they are now, making our view of the cosmos a kind of time machine built from light and distance. Perhaps the most beautiful aspect of all this cosmic motion is how it connects us to everything else. The calcium in our bones was forged inside dying stars. The iron in our blood was scattered across space by ancient supernovas. We're not just riding along with the galaxy, we're made from its recycled materials, temporary arrangements of stellar dust that learn to think and wonder about their own origins. Stars don't stay locked in one place within our galaxy's spiral arms. They actually drift through them over millions of years. They actually drift through them over millions of years. Think of it like cars moving through patches of heavy traffic, on an endless highway, sometimes caught in the thick of it, sometimes finding open road. The spiral arms themselves are more like slow-moving waves of star formation, density patterns that sweep around the galaxy's disk. Standing inside the Milky Way makes it incredibly difficult to see its true shape. We're like people trying to map an entire forest while standing right in the middle of it. All we see are individual trees, scattered leaves, glimpses of sky through branches. The bigger picture requires careful detective work, piecing together clues from star positions, gas cloud movements, the light from distant objects. What astronomers discovered through this patient mapping is remarkable. The galaxy moves with surprising organization, almost like a vast cosmic machine. Stars closer to the galactic center race around their orbits much faster than those living out in the suburbs. It's similar to how carousel horses near the center complete their circles quicker than the ones riding the outer edge. But here's where things get mysterious. When scientists calculated how fast stars should be moving, based on all the visible matter they could see, the numbers didn't add up. Stars on the galaxy's outskirts were moving way too fast. They should have been flung out into space long ago. Something invisible had to be holding them in their orbits. This puzzle led to one of modern astronomy's biggest questions, the existence of dark matter. Imagine a massive invisible scaffolding surrounding our entire galaxy, extending far beyond the bright disk of stars we can actually see. This dark matter doesn't glow, doesn't interact with light in any way we can detect directly. Yet, its gravitational influence shapes every star's path, every gas cloud's journey. The galaxy becomes a kind of cosmic dance, where the most important partner remains completely hidden from view. We can see the effects of this invisible partner in every measurement, every calculation of stellar motion. Dark matter forms what scientists call a halo, a spherical shell of unseen mass that keeps our spiral galaxy stable across billions of years. This hidden architecture helps explain why the Milky Way seems so unchanging from our human perspective. The forces are balanced in a delicate equilibrium. Gravity pulls inward while orbital motion carries everything sideways, creating stable paths that stars can follow for eons. Gas clouds drift along these gravitational highways, sometimes colliding and condensing into brilliant new stars, sometimes getting blasted apart by supernova explosions. All of this cosmic activity happens constantly, but across such enormous scales of space and time that it appears almost frozen from our brief human viewpoint. If you could somehow speed up time like fast-forwarding through billions of years of cosmic history, the stillness would disappear completely. Stars would streak around the galactic center in glowing trails. Spiral arms would slowly wind up and reorganize. Clouds of gas would flicker with the births and deaths of countless stellar generations. The galaxy would transform from something that looks like a static photograph into a living, breathing organism, constantly reshaping and renewing itself. New stars would blaze to life in brilliant blue clusters, then gradually redden and fade as they aged. Supernovas would flash like cosmic fireworks, sending shock waves that trigger the next generation of star formation. But the Milky Way's motion doesn't exist in isolation. Our galaxy belongs to what astronomers call the local group, a small collection of maybe 50 galaxies all bound together by their mutual gravitational attraction. Think of it as a cosmic neighborhood, where all the houses are slowly orbiting around their shared center of mass. The two largest members of this group, our Milky Way and the nearby Andromeda Galaxy, dominate the gravitational conversation. Their combined mass influences the paths of dozens of smaller dwarf galaxies that orbit around them like cosmic satellites. These dwarf galaxies follow complex, looping trajectories that can take billions of years to complete. From far away, this local group might look like an incredibly slow waltz, with galaxies as dance partners moving to a rhythm measured in hundreds of millions of years. There are no sudden moves, no dramatic changes in direction. Just the patient, inevitable pull of gravity guiding these island universes through their ancient choreography. The Andromeda Galaxy, our nearest large neighbor, is actually approaching us. In about 4.5 billion years, these two spiral galaxies will merge in what astronomers sometimes call a galactic collision. Though collision might be the wrong word, since the distances between individual stars are so vast that very few would actually hit each other. It would be more like two ghost ships passing through each other, their gravitational fields stirring up new patterns of star formation. Even beyond our local group, the cosmic dance continues on ever larger scales. Groups of galaxies cluster together, and those clusters gather into superclusters. These superclusters trace out vast filaments across the observable universe, creating a web-like structure that spans billions of light years. Our entire Milky Way, with its hundreds of billions of stars, becomes just one tiny glowing thread in this cosmic tapestry. Our galaxy drifts through space, like a leaf carried by invisible streams. The Milky Way moves at hundreds of kilometers per second, pulled by forces we can barely see. This motion isn't random, it follows patterns written into the very fabric of space itself. When astronomers measure our galaxy's movement, they compare it to something called the cosmic microwave background. This is the faint glow left over from the early universe, filling every corner of space. Against this ancient light, we can see that the Milky Way heads toward a particular region, drawn by enormous concentrations of mass. We're not alone in this journey. Thousands of other galaxies in our cosmic neighborhood drift in the same general direction. It's as if we're all sliding down the same gentle slope, carved by gravity into the structure of space. This creates what scientists call the cosmic web, a vast network of matter stretching across billions of light years. The idea that space has a shape, molded by mass and energy, transforms how we think about movement itself. Gravity doesn't just pull objects toward each other, it actually bends the paths that objects naturally follow. Picture a marble rolling on a curved surface. The marble thinks it's traveling straight, but the curve guides its motion. Our galaxy contains roughly 200 billion stars, all held together by gravity. This same force that keeps us orbiting the Sun also binds the entire Milky Way into a spinning disk. But the mass we can see, all those stars and gas clouds, only accounts for about 10% of what's actually there. The rest is dark matter, invisible stuff that reveals itself only through its gravitational effects. This dark matter forms a huge halo around our galaxy, extending far beyond the visible stars. Without it, the Milky Way would fly apart, its outer regions spinning too fast to stay connected. Meanwhile, the universe itself expands, stretching space between distant galaxies. This expansion doesn't affect us locally, because gravity holds everything together on smaller scales. But it shapes the cosmic stage, where our galaxies dance, unfolds, like a slow current beneath faster moving waters. All this motion happens in layers, each with its own rhythm and scale. Earth spins once each day, orbits the Sun once each year. The Sun carries us around the galaxy once every 200 million years. The galaxy itself drifts through space on timescales, so long they dwarf human history. Yet from our perspective, the night sky appears almost perfectly still. The same constellations that guided ancient sailors still shine in familiar patterns. This stability emerges not from the absence of motion, but from motion so vast and measured that it creates its own kind of peace. The stars do slowly change their positions over thousands of years. Polaris won't always serve as our North Star. The Big Dipper will gradually stretch and distort until future astronomers won't recognize it. But these changes unfold so gradually that dozens of human generations can find comfort in the same stellar landmarks. There's something profound about being part of a system in constant motion that still provides such steadiness. Your daily experience of solid ground and predictable surroundings doesn't require the universe to be frozen in place. It only requires that everything around you shares the same motion, like passengers on a smoothly sailing ship. This shared movement creates what we might call dynamic stability. The air doesn't rush past you because it travels with Earth through space. The ground doesn't slip away because it participates in the same orbital dance around the Sun. Your coffee cup stays on your table because it joins the same galactic journey as everything else in your room. Even dark matter, invisible and mysterious, contributes to this stability. It provides the gravitational scaffolding that keeps galaxies intact across billions of years. Without dark matter's steady influence, the cosmic web would collapse, and the universe would look completely different. The expansion of space adds another layer to this cosmic choreography. On the larger scales, galaxies race away from each other as space itself stretches. But this expansion is smooth and predictable, following equations that describe the universe's overall evolution. Scientists can trace this expansion backward to map the universe's history. They find that everything once existed in a much denser, hotter state. The same forces driving expansion today have been reshaping cosmic structure for nearly 14 billion years. Our galaxy formed from small fluctuations in this early universe, tiny variations in density that grew over time. Gravity amplified these differences, pulling matter together into the first stars, then star clusters, then entire galaxies. The Milky Way assembled itself gradually, absorbing smaller galaxies and growing into its current spiral shape. This process continues today. Our galaxy slowly cannibalizes nearby dwarf galaxies, incorporating their stars into our own structure. In a few billion years, we'll merge with the Andromeda galaxy, creating something entirely new. But even this dramatic collision will unfold with cosmic patience. The actual merger will take hundreds of millions of years, plenty of time for any observers to adjust to their changing sky. Individual stars rarely collide during galactic mergers because space between them remains so vast. All these movements, from planetary orbits to galactic drift, happen without conscious direction or intent. The universe doesn't plan its evolution. It simply follows the mathematical relationships between matter, energy, and space. Gravity pulls, momentum carries, expansion stretches, and patterns emerge from these simple interactions. Yet here we are, conscious beings capable of contemplating these vast motions. We can measure galactic velocities, map dark matter distributions, and predict cosmic futures. Through us, the universe develops a kind of self-awareness, even if only briefly and partially. This perspective offers a different way to think about rest and motion. True stillness might be impossible in a universe where everything constantly moves. But perhaps rest isn't about stopping movement, it's about finding harmony within motion. Like a dancer who appears perfectly balanced while spinning, you exist inside a vast rotating mechanism that spans 100,000 light years across. The Milky Way galaxy doesn't ask for your permission or your attention, it simply carries you along with the same quiet patience it has shown for billions of years. Every single atom in your body belongs to this enormous spiral system. Every heartbeat happens within its gravitational embrace. Most people think of galaxies as distant objects, beautiful spirals you might see in photographs, floating serenely against black space. But that's not your reality. You're living inside one right now, experiencing it from within, like standing in the middle of a slow, glowing snowfall, where lights stretch away in every direction. Some stars shine bright and relatively close, others barely whisper their light across unimaginable distances. There's something profoundly humbling about realizing you can't see the edges of your own cosmic home. No clear boundaries, no obvious center point, just layer upon layer of stellar depth, fading gently into darkness. The whole system rotates, but so slowly, so smoothly, that human senses can't detect the motion. You're like a passenger on the steadiest train imaginable, where only the distant countryside seems to move. The space between stars contains mysteries that dwarf our everyday understanding. If you shrank our sun down to the size of a single grain of sand, the nearest star would still be several kilometers away. The galaxy is mostly emptiness, but not the kind of emptiness that means nothing exists. It's filled with invisible currents of gravity, thin streams of gas, particles of dust that catch and scatter starlight. Right now, in this exact moment, you're participating in multiple journeys simultaneously. The Earth spins beneath you, creating the rhythm of day and night. The Earth orbits the Sun, giving you seasons and years through its tilted, looping path. The Sun itself follows a majestic orbit around the galactic center, a journey so vast it takes hundreds of millions of years to complete just once. And beyond that, the entire galaxy moves through space, responding to the gravitational pull of neighboring galaxies, part of an even larger cosmic dance. You're riding inside a stack of motions, each one nested within another, like invisible gears, turning together in perfect coordination. Yet somehow, from your perspective, everything feels still enough that you can close your eyes and rest. This layered motion creates something almost paradoxical. You're traveling through space at extraordinary speeds, but the experience feels gentle, stable, predictable. It's like floating on the surface of an incredibly wide, slow-moving ocean where the waves barely disturb your peaceful drift. The horizon looks essentially the same in every direction. The sky above remains steady, and without some distant marker to measure against, you might never realize you're moving at all. The stars around you behave like points of light, scattered across that cosmic ocean, all moving together in patterns too immense to grasp completely. Some stars race ahead in their orbits, others lag behind, creating the spiral arms that give our galaxy its distinctive shape when viewed from impossible distances. But from inside, these patterns reveal themselves, slowly, subtly, across timescales that make human lifetimes seem like brief flickers. Consider how this changes the meaning of stillness itself. When you sit quietly, when you feel at rest, you're actually participating in one of the universe's grandest movements. Your stillness exists within motion. Your peace occurs during an epic journey that began long before life appeared on Earth and will continue long after the sun exhausts its nuclear fuel. The galaxy's rotation carries implications that stretch far beyond simple movement through space. It mixes and redistributes the elements that make life possible, spreads the heavier atoms forged inside dying stars throughout the cosmic neighborhood. Iron, carbon, oxygen, all the materials that compose your body have likely traveled multiple times around the galactic center, carried by previous generations of stars. There's something deeply satisfying about belonging to such a vast, patient system. The Milky Way doesn't hurry, doesn't worry about schedules or deadlines. It simply continues its ancient rotation, indifferent to human concerns, but somehow providing the stable foundation that makes those concerns possible. Your breathing, your thinking, your dreaming, all happen within this context of cosmic serenity. The darkness between stars isn't empty darkness, it's pregnant with potential. Clouds of gas and dust drift through these regions, slowly condensing under their own gravity, eventually forming new stars, new planetary systems, new possibilities for complexity, and perhaps consciousness. The galaxy constantly renews itself, recycling matter and energy in cycles that span millions and billions of years. From your position inside this system, motion becomes something subtle and profound. You can't point to any single moment when the galaxy has obviously shifted. Can't feel the centrifugal forces that keep everything in orbital balance. The change happens too slowly, too smoothly, for human perception to register directly. But that doesn't make it less real, just less obvious, like the growth of mountains or the drift of continents. The universe operates on a principle that might seem counterintuitive at first. Most of what we think of as space isn't really filled with anything at all. It's this profound emptiness that makes the cosmic dance possible. Without all that vacant territory between stars, celestial bodies would be crashing into each other constantly, like bumper cars at a carnival that never stops. Our sun doesn't just sit there, anchored in one spot. It travels through space in what you might call a wobbly oval, sometimes swinging closer to the galaxy's heart, sometimes drifting farther away. Picture a child on a swing, but instead of going back and forth, the motion stretches into a long, gentle loop that takes millions of years to complete. But there's more to this movement than just the horizontal journey. The sun also rises and falls, like a dolphin swimming through invisible ocean currents. This up and down motion carries our entire solar system above and below what astronomers call the galactic plane. Think of it as the thick, star-dense middle section of the Milky Way, like the cream filling in a cosmic sandwich. Each complete rise and fall takes tens of millions of years. During this incredibly slow oscillation, our solar system passes through neighborhoods that vary dramatically. Sometimes we're cruising through regions packed with stars and swirling gas clouds. Other times we find ourselves in the quiet suburbs of space, where stars are scattered and sparse. These changes happen so gradually that 100 human lifetimes wouldn't be enough to notice the difference. But over the vast stretches of geological time, these shifting cosmic environments might actually influence what happens here on Earth. Some researchers have wondered whether traveling through denser regions could send more comets tumbling toward our inner solar system, like stirring up a hornet's nest as you walk by. There's also the possibility that different radiation environments could leave subtle fingerprints in Earth's biological history. It's a fascinating idea, though incredibly difficult to prove. The notion that our planet's story might be partially written by our galaxy's wanderings adds another layer to the already complex relationship between the very large and the very small. Every star you can see in the night sky is on its own unique journey. None of them are moving in exactly the same direction, or at the same speed. Each one follows a path shaped by its distance from the galactic center, the gravitational pull of nearby stars, invisible clouds of gas, and the mysterious dark matter that wraps around our entire galaxy like an unseen blanket. Over enormous spans of time, these individual stellar paths slowly spread out and mix together. Astronomers have a term for this process. They call it dynamical heating. It's similar to how cream slowly swirls through coffee, gradually changing the whole mixture. The result is that our galaxy isn't a perfectly flat, orderly disk. Instead, it's a thick, gently stirred system where stars can wander far from where they were born. This cosmic shuffling means something quite remarkable about our sun's history. The stars that surround us today are not the same ones that were our neighbors when the solar system was young. About 4.5 billion years ago, our sun formed alongside dozens or maybe hundreds of other stars, all emerging from the same vast cloud of gas and dust, like seeds scattered from the same pod. Over time, that original stellar family dispersed. Each member drifted away along its own galactic path, following the invisible currents of gravity and motion. Today, those sibling stars are scattered across the Milky Way, lost among hundreds of billions of other suns. Most of them are now unrecognizable, anonymous points of light in the cosmic crowd. The stellar neighborhood we see today is really just a temporary arrangement. It's like looking at the people sitting around you on a long train journey, knowing that everyone will eventually get off at different stops. What seems permanent is actually just a moment in a very long, very slow reshuffling of cosmic addresses. When you step outside on a clear night and look up, the light entering your eyes carries this story of motion and time. Some of the stars are close enough that their light left them just a few years ago. It's almost like getting a recent photograph in the mail. But others are so incredibly distant that their light began its journey to Earth before human civilization even existed. In a very real sense, looking at the night sky means looking backward through time. You're not seeing where those stars are now, but where they were when their light first started traveling toward you. It's like watching the wake of a boat long after the vessel itself has moved on. As our galaxy continues its ancient rotation, those points of light are shifting position, even though the change is far too small to notice from one night to the next. There's something quietly profound about this realization. The sky that feels so constant, so reliable as a backdrop to our daily lives, is actually a moving record of the past. Every constellation, every familiar star pattern is like a footprint in wet sand, slowly changing shape as the long tide of galactic time washes over it. The space between stars isn't completely empty though. Vast clouds of gas and dust drift through the Milky Way like invisible weather systems. These clouds are the raw material from which new stars and planets will eventually form, and they're anything but still. They swirl and stretch, compress and collide, all under the influence of gravity and the shock waves that ripple out from dying stars. When a massive star reaches the end of its life, it doesn't just fade away quietly. Instead, it explodes in what astronomers call a supernova, sending a shell of energy racing outward at incredible speeds. These stellar explosions stir the surrounding material like a giant spoon mixing ingredients in a cosmic bowl. Sometimes these disturbances can actually trigger the collapse of nearby gas clouds, starting the whole process of star formation all over again. So even as our galaxy follows its long, steady rotation, its interior is full of smaller, more local motions and changes. It's a layered system where calm, large-scale movement coexists with pockets of dynamic, energetic transformation. From our tiny vantage point, there's something almost comforting about thinking of the Milky Way not as a rigid, unchanging structure, but as a living environment that's constantly renewing itself through slow, patient cycles that span millions of generations. The Milky Way lives surrounded by a family of smaller galaxies, dozens of them scattered through space like distant cousins. These dwarf galaxies orbit our massive spiral, some so faint they're barely visible even with powerful telescopes. It's a cosmic neighborhood that's constantly changing, reshaping itself through gravitational conversations that have been going on for billions of years. Some of these smaller companions drift too close to our galaxy's gravitational embrace. When this happens, they begin to unravel. Their stars get stretched out into long, thin streams that wind around the Milky Way like cosmic ribbons. These stellar streams tell stories of ancient encounters, marking the paths where smaller galaxies met their fate. Each stream represents what was once a complete star system, now scattered across millions of light years. This process reveals something profound about how galaxies grow. The Milky Way isn't a finished creation, sitting unchanged in space. It's more like a living entity that keeps absorbing new material, adding new chapters to its story. Every small galaxy that ventures too near becomes part of our extended cosmic family. Their stars join the slow, ancient rotation around our galactic center. Their gas clouds might someday birth new suns. The very heart of our galaxy demonstrates this restless nature most dramatically. At the center sits a supermassive black hole, surrounded by stars moving at incredible speeds. These central stars trace tight orbits in an incredibly strong gravitational field, completing their journeys in just years or decades, rather than the millions of years it takes for stars like our Sun to orbit once. Clouds of gas spiral inward toward this dark core, heating up and glowing as they fall deeper into the gravitational well. From far away, this central activity appears as a steady glow, but up close, it's a dynamic, chaotic environment where matter and energy dance at the edge of what's possible. Stars accelerate to thousands of kilometers per second. Gas reaches temperatures of millions of degrees. It's a reminder that even the most seemingly permanent features of our galaxy are actually in constant flux. All of this movement follows the rules of gravity, but gravity itself isn't the simple force we might imagine. Modern physics tells us that gravity is actually the curvature of space-time itself, created by the presence of mass and energy. The Milky Way doesn't just move through space like a ship sailing across a calm ocean. Instead, it shapes the very fabric of the universe as it goes, creating curves and ripples in space-time that influence everything around it. Think of lying on a soft mattress. Your weight creates a depression, and if you roll to one side, the shape changes with you. You're not just moving across the surface, you're actively reshaping it. Massive objects like galaxies do something similar to the fabric of space and time. They create gravitational wells that guide the motion of everything nearby, from individual stars to entire galaxy clusters. This means our galaxy participates in shaping the very space through which it moves. It's simultaneously the traveler and the architect of its own path. The distinction between the mover and the medium becomes blurred at these cosmic scales. Space isn't empty and unchanging, it's dynamic and responsive, constantly adjusting to the masses that inhabit it. Meanwhile, smaller rhythms continue undisturbed. Hearts beat, lungs expand and contract, thoughts rise and fall like waves on a shore. These intimate motions exist alongside the grand galactic dance, neither dependent on nor disturbed by the vast choreography happening around them. There's something deeply comforting about this layering of scales, how cosmic motion and personal stillness can coexist so peacefully. The galaxy spins and drifts and grows, influenced by forces that span millions of light years and billions of years. Dark matter halos shift and merge, stellar streams wind through space, gas clouds collapse into new generations of stars. Yet none of this cosmic activity demands our attention or participation. The vastness operates on its own timeline, patient and unhurried, creating space for smaller moments of peace and reflection within its grand design. Our galaxy moves in ways that completely reshape how we think about motion itself. The Milky Way spins around its center, taking roughly 220 million years to complete one full rotation. That means the last time our solar system was in this exact spot, dinosaurs hadn't even appeared yet. But rotation is just one layer of movement. The entire galaxy drifts through space, pulled by gravitational forces from neighboring galaxies. Andromeda, our nearest large galactic neighbor, actually tugs at us across the vast emptiness. In about 4.5 billion years, these two spiral galaxies will merge into something completely new. The local group, which includes the Milky Way, Andromeda, and dozens of smaller galaxies, moves as a unit too. We're all falling toward a massive cluster of galaxies, called the Virgo cluster. It contains over 1,000 galaxies, and its gravitational pull reaches across millions of light years. Even the Virgo cluster participates in larger motions. Astronomers have discovered something called the Great Attractor, a gravitational anomaly that pulls our entire local region of the universe toward it. But here's where things get really strange. The Great Attractor itself might be falling toward an even larger structure. Dark matter complicates this picture in fascinating ways. This invisible substance outweighs regular matter by about 5 to 1 in our galaxy. We can't see it directly, but we can measure how it shapes the movement of stars and gas clouds. Dark matter creates a kind of scaffolding that guides how galaxies move and interact. The expansion of space adds another layer entirely. While galaxies move through space, space itself stretches, carrying distant galaxies away from us. This cosmic expansion means that the very stage on which galactic motion plays out is constantly changing. When you try to pin down exactly how fast the Milky Way moves, the question becomes surprisingly complex. Relative to the cosmic microwave background, the leftover radiation from the Big Bang, we're traveling at about 600 kilometers per second. That's more than 1,000,000 miles per hour. But motion always depends on your reference point. From the perspective of someone on the surface of Earth, the galaxy seems motionless. From the viewpoint of a distant galaxy, our motion looks completely different. There's no absolute cosmic rest frame, no universal standard for stillness. This relativity of motion reflects something deeper about the nature of the universe. Nothing exists in isolation. Everything moves in relationship to everything else. The Milky Way's path through space emerges from its interactions with dark matter, nearby galaxies, and the expanding fabric of space-time itself. Ancient astronomers thought the celestial sphere rotated around a stationary Earth. Then we learned that Earth orbits the Sun. Later, we discovered that the Sun orbits the galactic center. Now we know that even galaxies participate in vast cosmic flows and currents. Each shift in perspective revealed that what seemed fixed was actually in motion. What appeared simple was actually layered with complexity. The universe operates more like a symphony than a machine, with countless movements happening simultaneously at different scales. Our solar system completes its galactic orbit so slowly that it's happened only about 20 times since the Milky Way formed. In cosmic terms, we're still in the early chapters of a very long story. The galaxy formed roughly 13 billion years ago, when the universe was much younger and smaller. Back then, galaxies collided and merged more frequently. The Milky Way bears the scars of these ancient encounters. Streams of stars scattered across the galactic halo tell the story of smaller galaxies that were torn apart and absorbed. Some of the stars in our night sky originally belonged to completely different galaxies. Galactic archaeology, the study of these stellar streams and chemical signatures, reveals the Milky Way's history of growth through merger and accretion. Our galaxy wasn't born fully formed, it assembled itself piece by piece over billions of years. The supermassive black hole at the galactic center, weighing about 4 million times as much as our Sun, plays a crucial role in organizing galactic motion. Stars near the center orbit this black hole at tremendous speeds, completing their circuits in just a few years rather than millions. Spiral arms add another pattern to galactic motion. These aren't rigid structures but density waves that sweep around the galaxy. Stars move in and out of spiral arms as they orbit. Our solar system has probably crossed spiral arms multiple times during its journey around the galaxy. Each passage through a spiral arm exposes us to different conditions. Higher concentrations of gas and dust, more frequent supernovae, different levels of cosmic radiation. Some scientists speculate that these crossings might influence climate and evolution on Earth over geological timescales. The interstellar medium, the thin gas and dust between stars, creates drag that affects stellar motion. This cosmic friction is incredibly weak, but over millions of years, it can subtly alter orbital paths. Stars don't move through completely empty space. They push through this tenuous but ever-present material. Globular clusters, ancient collections of hundreds of thousands of stars, follow their own eccentric orbits around the galaxy. These stellar cities are among the oldest objects in the Milky Way, and their paths take them far above and below the main galactic disk. The galactic halo, a roughly spherical region surrounding the main disk, contains most of the galaxy's dark matter. This invisible component creates the gravitational framework that holds everything together. Without dark matter, the outer regions of the galaxy would fly apart. Star formation in the Milky Way has slowed dramatically over the past few billion years. The galaxy consumed much of its available gas in an earlier, more active phase. Today, new stars form at a much more leisurely pace, mostly in spiral arms where gas clouds compress and collapse. Our position in the galaxy, roughly halfway between center and edge, sits in what astronomers call the habitable zone. Too close to the center, and radiation from the supermassive black hole and frequent supernovae would sterilize planets. Too far out, and heavy elements necessary for rocky planets become scarce. This galactic habitable zone concept suggests that the Milky Way's motion through space isn't just a cosmic curiosity, it's part of the story of how Earth became a world where life could emerge and persist. We orbit not just a star, but a carefully balanced position within a galaxy that has been stable enough for billions of years. The future holds dramatic changes. As the universe continues expanding, distant galaxies will disappear beyond our observational horizon. Eventually, only the local group will remain visible. The cosmic perspective that we take for granted today will become impossible for future astronomers, but that's still trillions of years away. For now, we find ourselves in a universe rich with motion, structure, and possibility. Every night, the sky above reveals a galaxy in constant, graceful motion, carrying us along on a journey that began billions of years ago and will continue long after our sun burns out. When you think about how fast you're moving right now, the answer might seem obvious at first. You look down at your feet, notice they're planted firmly on the ground, and conclude you're perfectly still. Your coffee cup sits motionless on the table. The walls around you haven't budged. Everything feels stable, unchanging, almost peaceful in its stillness. But the universe tells a completely different story. This simple question, how fast are you moving, opens up layers of motion that most of us never consider. It's like peeling back the curtain on reality itself, revealing that stillness is really just an illusion we create from our limited perspective. Motion, as physicists understand it, is always relative. You need to ask yourself, moving compared to what? Picture yourself sitting on a train that's gliding smoothly down the tracks. The passenger across from you appears completely stationary. They're sipping their drink, reading quietly, not moving an inch from your point of view. But someone standing on the platform outside sees both of you rushing past at high speed. Neither perspective is wrong, they're just different reference points. This same principle applies to your position in the cosmos. Relative to your chair, you're motionless. Relative to the center of Earth, you're spinning. Relative to the sun, you're racing through space at incredible speeds. And relative to distant galaxies, you're moving in ways that sound almost impossible to believe. Let's start with the most immediate motion happening right beneath you. Earth rotates once every 24 hours, carrying you along for the ride. If you're sitting near the equator right now, you're being swept around in a massive circle at about 1,600 per hour. That's roughly the cruising speed of a commercial jet aircraft. The closer you are to the poles, the slower this rotational speed becomes, because the circle you're traveling gets smaller. But even if you're far from the equator, you're still moving at hundreds of kilometers per hour, just by existing on this spinning planet. You don't feel this rotation because everything around you moves with you. The air you breathe, the buildings outside, the trees swaying in the breeze, even the vast oceans. They're all part of the same rotating system. There's no sudden jolt, no change in speed that your body can detect. Motion at constant velocity, when it's shared by everything in your environment, becomes nearly invisible. Think about how strange this is from a philosophical standpoint. We build our understanding of reality based on what we can sense directly, but here's proof that our senses can miss some of the most fundamental truths about our existence. We're always in motion, always traveling through space, even in our most quiet moments. On top of Earth's daily spin, there's another layer of movement. Our planet orbits the Sun at approximately 107,000 kilometers per hour. That's fast enough to circle the entire Earth almost 3 times in 60 minutes. This orbital motion is so smooth and consistent that from our perspective, It appears the sun is the one doing the moving, rising, and setting each day. So just by being on this planet, without taking a single step, you're already moving at combined speeds that can easily exceed 100 kilometers per hour, depending on how these different motions add together at any given moment. But the story gets even more remarkable. The sun itself isn't some fixed point in space. It's racing around the center of the Milky Way galaxy, carrying all of its planets along for the journey. This galactic orbit involves truly staggering speeds. Our solar system, including Earth and you, travels through space at about 220 kilometers per second. That translates to nearly 800,000 kilometers per hour. At that speed, you could travel from Earth to the Moon in less than 30 minutes. You could circle our entire planet about 20 times in a single hour. And yet here you might be, feeling perfectly at rest, maybe even getting drowsy, completely unaware of this cosmic dance you're participating in every second of your life. This galactic motion follows a predictable pattern. The sun traces a long, graceful path around the center of our galaxy, completing one full orbit roughly every 230 million years. Scientists sometimes call this a galactic year, and it puts human timescales into humbling perspective. The entire recorded history of human civilization represents just a tiny fraction of one galactic year. The last time our solar system was in its current position relative to the galaxy's center, dinosaurs ruled the Earth. The next time we complete this orbit, who knows what forms life might take, or if humans will even exist to witness it. There's something both unsettling and wonderful about discovering these hidden layers of motion. It challenges our intuitive understanding of what it means to be at rest. Perhaps true stillness doesn't exist anywhere in the universe. Everything is always moving relative to something else, participating in this endless cosmic choreography. Even the galaxy itself isn't stationary. It's part of a larger dance with neighboring galaxies, all of them moving through the expanding fabric of space itself. The deeper you look into this question of motion, the more you realize that the universe is fundamentally restless, fundamentally dynamic. Your sense of being still, that peaceful feeling of being grounded and stable, is really just the result of sharing motion with everything around you. It's like being in the world's largest, smoothest vehicle, one so well designed that you never feel the incredible journey you're on. This realization can shift how you think about your place in the cosmos. You're not a stationary observer watching the universe unfold. You're an active participant, racing through space at speeds that would make the fastest human inventions seem sluggish by comparison. The cosmic dance we're part of unfolds in ways that would make your head spin. If only you could actually feel it happening. Right now, as you sit there listening to this, you're hurtling through space at speeds that dwarf anything we experience in our daily lives. Yet your body registers none of it, treating this incredible journey as if it were perfectly ordinary. Think about this for a moment. The ground beneath your feet is spinning, carrying you along as Earth rotates on its axis. At the same time, our entire planet swoops around the sun in a vast oval path, covering millions of kilometers every single day. But that's just the beginning of the motion story. Our sun, along with all its planets, orbits the center of the Milky Way galaxy. This journey is so enormous that even though we're moving at tremendous speeds, it takes roughly 220 million years to complete just one lap. When you consider that complex life on Earth hasn't even been around for one full galactic year, it puts things into perspective. Dinosaurs came and went in what amounts to a fraction of this immense cycle. Now here's where it gets really interesting. Our galaxy isn't just sitting still in space either. The Milky Way belongs to what astronomers call a local group, a small collection of galaxies that are all gravitationally bound together. Within this cosmic neighborhood, galaxies drift toward and away from each other, pulled by invisible forces. The Milky Way and its largest neighbor, the Andromeda Galaxy, are slowly approaching each other at about 100 kilometers per second. That's another layer of motion, another current in this cosmic river we're all riding together. And beyond that, our entire local group is moving through the larger structure of the universe. Scientists have figured this out by looking at something called the cosmic microwave background radiation. This faint glow fills all of space, leftover heat from the early universe. It provides a kind of cosmic reference frame, like a universal measuring stick for motion. When astronomers study this background radiation, they discover that our galaxy is racing through space at roughly 600 kilometers per second in a particular direction. That's more than 2 million kilometers per hour. This mind-boggling speed comes from the gravitational pull of massive structures in our cosmic neighborhood. Clusters of galaxies, concentrations of dark matter, all tugging on us in ways we can't directly perceive. When you add up all these layers of movement, Earth's rotation, our orbit around the sun's orbit around the galaxy, and the galaxy's motion through space, you get a picture where you, right now, are traveling at speeds that can easily reach millions of kilometers per hour. The truly remarkable thing is how completely unaware we are of this motion. There's something almost magical about that disconnect. You're part of an incredibly fast, incredibly complex journey through the cosmos, and your nervous system treats it as if absolutely nothing is happening. This isn't because your body is somehow broken or failing to notice something important. It's because from the perspective of your senses, this type of motion simply doesn't matter. What your brain cares about are changes, sudden shifts, things that accelerate or decelerate in ways you can actually feel. This is exactly why you notice when a car speeds up, slows down, or takes a sharp turn, but you don't feel anything when it cruises steadily down a smooth highway. It's why you can fall asleep on an airplane traveling at nearly 900 kilometers per hour, as long as the ride stays smooth. Constant, steady motion just becomes part of the background, something your brain learns to ignore. Your senses evolved to pick up on changes that matter for survival on a human scale. A sudden sound might signal danger approaching. A shift in lighting could mean weather is changing. A temperature drop might mean you need to find shelter. But the slow, steady motion of planets and galaxies doesn't carry immediate consequences for your daily survival, so your brain doesn't waste energy paying attention to it. If you really think about it, though your ability to ignore these enormous speeds represents a quiet triumph of cosmic stability, it means the systems you're part of, Earth, the solar system, our galaxy, are all moving in ways that are fundamentally balanced and predictable. They're not tumbling chaotically through space like cosmic pinballs. Instead, they follow paths shaped by gravity and the deep structure of the universe, paths that have remained stable for billions of years. This stability is actually what makes life possible in the first place. If Earth's orbit were wildly irregular, our climate would swing between extremes too quickly for ecosystems to adapt. If our galaxy were a violent, unstable place, stars and planets would be constantly disrupted by close encounters with other objects. The calm, steady motion you don't even notice provides the foundation for every quiet moment you get to enjoy. There's another way to think about cosmic speed that makes it feel less abstract. Instead of focusing on kilometers per hour, consider the actual distances you travel over time. In the few minutes it takes to listen to this section, Earth will carry you tens of thousands of kilometers along its orbital path around the Sun. The Sun will carry you millions of kilometers along its journey around the galaxy. The galaxy itself will transport you even further through the larger cosmic landscape. You don't leave any visible trail behind you in space. But if you could somehow mark your position at this exact moment and compare it to where you'll be in just a few minutes, the separation would be absolutely vast. The universe is constantly giving you a new address, even though you never notice the change of scenery. This idea can feel a little disorienting at first. We're used to thinking of ourselves as being in a fixed place, with the world moving around us in small, manageable ways. But on a cosmic scale, there really is no single, permanent location. There are only relationships between objects, distances that constantly change over time, and patterns of motion that unfold across enormous spans of space and time. If you let that concept settle in for a moment, it can actually feel strangely liberating. You're not stuck at a single point in some vast empty void. Instead, you're part of a moving system, a flow of matter and energy that connects you directly to stars, galaxies, and the larger architecture of the universe. Your speed, however impressive it sounds, in raw numbers, isn't something you need to manage or worry about. It's simply part of a shared journey we're all taking together. There's something wonderfully unhurried about the way the universe operates. Despite all this incredible speed, the distances involved are so vast that even when moving at hundreds of kilometers per second, galaxies still take billions of years to actually encounter each other. The Milky Way and Andromeda are approaching each other right now, but their eventual collision is so far in the future that it exists more as a story for distant generations of stars than as any kind of urgent event. Speed in this cosmic context becomes almost poetic. Fast and slow lose their everyday meanings when you stretch them across such enormous scales. A process that seems unimaginably slow to humans, like the rotation of an entire galaxy, can simultaneously be described as incredibly fast when you measure the actual kilometers covered every second. The same motion is both glacially slow and lightning quick, depending entirely on your perspective. Your own body reflects this same paradox in miniature. The atoms inside you are in constant frantic motion. Electrons zip around nuclei, molecules vibrate and dance. Chemical reactions happen thousands of times every second in every single cell, yet you experience yourself as a solid, stable, coherent whole. Motion and stillness coexist peacefully at different levels within the same system. The galaxy works the same way. It's absolutely full of movement, from the smallest scales of particles and electromagnetic fields, all the way up to the grand motions of stars and invisible dark matter. But from the inside, from our perspective as residents within it, it feels like a quiet, steady, reliable home. Sometimes, people find deep comfort in the idea of standing still, of being grounded, of having some fixed place in the world to call their own. Learning about cosmic motion doesn't have to take any of that away. You can still feel grounded in your own body, in your breathing, in whatever room you happen to be sitting in right now. The fact that all of it is moving together through space doesn't make it any less real or any less present. In fact, understanding cosmic motion can make this present moment feel more vivid and precious. This exact moment, right now as you listen to these words, is unique in the most literal sense possible. You will never occupy this precise position in space and time again. The universe is constantly shifting and evolving, and you're shifting right along with it. Every single second represents a completely new combination of location, motion, and experience that will never be repeated in exactly the same way ever again. You don't need to treat that as something dramatic or overwhelming. It can simply be a quiet observation, like noticing that the light in your room has changed slightly as the day progresses, or that the background sounds from outside have shifted and softened. It's just another layer of the ongoing flow that you're naturally part of. Another thread in the cosmic tapestry that connects every atom in your body to the furthest reaches of space and time. The sun moves through space in ways that escape our everyday awareness, carrying us along on a journey so vast and slow that human minds struggle to grasp its scale. We feel the warmth on our faces each morning, watch the familiar dance of sunrise and sunset, yet remain completely unaware that we are passengers on a cosmic voyage that has been unfolding for billions of years. Our solar system sits roughly 26,000 light-years from the center of the Milky Way galaxy. To put that distance in perspective, if you could travel at the speed of light itself, the fastest thing in the universe, it would still take 26,000 years to reach the galactic center. The sun moves around this center at an incredible speed, about 220 kilometers every second, yet even at this breakneck pace, it takes roughly 230 million years to complete just one orbit. This time frame, called a galactic year, stretches beyond human comprehension. Since the sun began its current orbit around the galaxy, entire mountain ranges have risen from the sea and crumbled back to dust. Continents have drifted across the planet's surface like slow-moving puzzle pieces. Species have evolved, flourished, and gone extinct, leaving only fossil traces of their existence. The center of our galaxy holds secrets that dwarf anything in our solar system. There, in that crowded cosmic downtown, sits a supermassive black hole called Sagittarius A star. This monster contains the mass of millions of suns, compressed into a region smaller than our solar system. Yet, despite its incredible mass, this black hole doesn't act like some cosmic vacuum cleaner, sucking up everything around it. Instead, it works together with billions of stars, vast clouds of gas, and an enormous halo of invisible dark matter to create the gravitational architecture that guides our sun's motion. The Milky Way itself resembles a giant spinning disk, thick in the middle and thin at the edges, with graceful spiral arms curling outward like cream stirred into coffee. Our sun doesn't follow a perfect circular path around this structure. Instead, its orbit resembles a stretched, slightly wobbly loop, influenced by the uneven distribution of matter throughout the galaxy, and the gentle gravitational tugs of nearby stars and gas clouds. As the sun travels this cosmic highway, it doesn't maintain a constant altitude relative to the galaxy's flat disk. Instead, it bobs up and down like a cork on gentle ocean swells, sometimes passing through the dense, crowded midplane, where most of the galaxy's stars and gas reside, other times venturing into the quieter suburbs above or below this stellar metropolis. These vertical oscillations happen over tens of millions of years, creating a kind of cosmic rhythm that has accompanied Earth through countless chapters of its history. When our solar system passes through denser regions of the galaxy, we encounter more cosmic rays, dust, and gravitational influences from neighboring stars. During quieter periods in the galactic countryside, space around us becomes more serene, less cluttered with the debris and radiation of stellar neighborhoods. The sun's distance from the galactic center also varies throughout its orbit, sometimes bringing us closer to that energetic core, other times carrying us farther into the galaxy's outer reaches. These changes happen so gradually that they leave no mark on human experience, yet they represent journeys across distances, so vast they make interplanetary travel seem like a short walk around the block. Consider that in the time it takes for our sun to complete just one lap around the galaxy, the entire story of complex life on Earth has unfolded multiple times over. The first simple organisms appeared, evolved into fish, crawled onto land, took to the skies, and diversified into millions of species. Ice ages have come and gone, like seasonal weather, on a planetary scale. This perspective reveals something profound about our place in the universe. We often think of the sun as fixed, permanent, the reliable center of our world. Yet it too is a wanderer, following ancient paths laid down by gravity and the distribution of matter across space. The very ground beneath our feet participates in this cosmic dance, carrying us through regions of space that no human eye will ever see directly. The night sky that our ancestors used to navigate and mark the seasons appears unchanged from our perspective. Yet we are actually moving through it at tremendous speed. The constellations that guided ancient civilizations shine from slightly different angles now than they did when the first humans looked up in wonder. The changes are too subtle and slow for any individual to notice, but they accumulate over the vast stretches of cosmic time. Our sun has likely completed fewer than 20 trips around the galaxy since it first ignited as a star. Each orbit represents an epic journey through different neighborhoods of space, past stellar nurseries where new suns are born, through regions where old stars explode and scatter their elements into space, around the outskirts where matter grows thin and space becomes truly empty. The fact that we can even know about this motion represents one of humanity's greatest intellectual achievements. For most of our species' existence, we remained completely unaware of this cosmic journey. Only in recent centuries have we developed the tools and understanding to map our position in the galaxy and calculate our motion through space. This knowledge transforms our understanding of permanence and change. What seems solid and eternal from a human perspective reveals itself as dynamic and flowing when viewed across cosmic time. The sun that appears so constant in our daily lives participates in motions and cycles that dwarf any earthly experience, connecting us to the largest structures and longest timescales in the universe. The galaxy holds mysteries that might touch our world in ways we've barely begun to understand. When the sun travels through different regions of space, it encounters areas where gas and dust cluster more densely. These denser neighborhoods could nudge the distant icy bodies at the edge of our solar system, perhaps sending ancient comets on long journeys toward Earth. The evidence remains scattered and hard to interpret, but it suggests that our planet's history might be written partly by the sun's changing address in the galaxy. There's something almost poetic about how spiral arms work in our galaxy. They aren't solid structures spinning like the spokes of a wheel. Instead, they're more like traffic jams, made of stars and glowing gas, places where matter naturally piles up as it moves around the galactic center. The sun doesn't live in just one of these arms forever. Over tens of millions of years, it drifts from one spiral arm to another, sometimes finding itself in bustling stellar neighborhoods, other times wandering through the quieter spaces between arms. Picture driving from a bright, busy city into peaceful countryside, except the city lights are massive stars, and the countryside still twinkles with distant suns. The transition happens so gradually that even across millions of years, the change feels gentle, yet these passages shape the broader story of where our solar system has been and where it's going. What keeps the sun from spiraling into the galaxy's center or drifting away into the void is a kind of invisible architecture. Dark matter, though we cannot see it directly, makes up most of the galaxy's mass. This hidden component acts like scaffolding, holding the Milky Way together and keeping stars like our sun in stable, long-lasting orbits. Without dark matter's gravitational embrace, the outer regions of the galaxy would fly apart. Stars would scatter into the loneliness of intergalactic space. This stability carries a quiet profundity. The sun, which dominates our daily experience, holds no special position in the galaxy's grand design. It's simply one star among hundreds of billions, following a path shaped by the combined gravitational influence of everything else. There's no cosmic spotlight, no privileged treatment, just participation in a vast, slow dance that connects our local star to distant regions we'll never see. The same forces guiding the sun's orbit also shape the motion of stars. So far away their light takes thousands of years to reach us. Gas clouds that might someday birth new solar systems follow similar rules. Even galaxies beyond our own move according to these same fundamental patterns. The warmth you feel from sunlight connects you to processes that reach all the way to the galactic center and beyond. The sun hasn't always followed its current path, and it won't continue this exact route forever. Galaxies grow by absorbing smaller neighbors. Their structure shifts as stars migrate, as gas gets consumed and replenished, as dark matter continues sculpting their form. These changes influence the sun's orbit, though the effects unfold too slowly for human lifespans to notice. Billions of years from now, our Milky Way will encounter its largest neighbor, the Andromeda Galaxy. When these two giants merge, both will transform dramatically. Stars will be flung into completely new orbits. Colliding gas clouds will trigger bursts of star formation. The central regions will combine, creating a larger, more complex galaxy. Through all this upheaval, the sun, if it's still shining, will find itself following a new path around a newly formed galactic heart. But that story lies far in the future. For now, the sun continues its steady journey, covering just a tiny fraction of one galactic orbit, while entire human civilizations rise and fall. This difference in timescales offers an odd kind of comfort. The galaxy's rhythms are so slow and stable that they provide an enduring background for the much faster rhythms of life on Earth. We usually think of the sun as our timekeeper, marking days and seasons, telling us when to wake and when to rest. But on cosmic scales, the sun keeps time in a completely different way, measuring out hundreds of millions of years with each slow loop around the galactic center. These two clocks, the daily and the galactic, tick together without ever truly intersecting. You could live countless lifetimes without the sun, completing even a small portion of its orbit, yet both rhythms flow within the same vast stream of time and motion. The sun's journey isn't perfectly smooth either. Nearby stars and gas clouds exert subtle gravitational influences, nudging its path slightly inward or outward, tilting its orbit or changing its vertical motion over very long periods. These tiny adjustments remind us that even on the grandest scales, the universe isn't rigidly mechanical. It's full of gentle interactions, small corrections, ongoing evolution. This makes the sun's motion feel less like clockwork and more like a long shared experience. Every star in the galaxy follows its own path, and together they weave a complex shifting pattern that's never exactly the same from one moment to the next. The sun doesn't travel alone. It moves as part of an enormous community of stars, all responding to the same gravitational currents. When sunlight falls through your window or warms your skin, that light traveled 93 million miles in just over 8 minutes. But the sun itself is in the middle of a much longer journey, one that began billions of years ago when it condensed from a cloud of gas and dust. Every ray of sunlight carries a piece of that larger story. It's not just energy from a nearby star, it's a moment in the ongoing motion of an entire galaxy, delivered to a small living world that happens to be passing by at just the right distance and time. This connection doesn't have to feel overwhelming. It can be simple and quiet, like knowing that the ground beneath you belongs to a planet, within a solar system, within a galaxy, within a universe. The sun's orbit around the distant galactic center mirrors something in human experience. We all follow routines and paths, daily, yearly, across our lifetimes. Most of the time we don't think about these patterns, we simply move through them, guided by habits and circumstances. But sometimes we pause and see the long arc of where we've been and how we've changed. The sun's journey stretches this idea across scales so vast they become almost abstract. Yet the underlying truth remains the same. Motion doesn't need to be fast or dramatic to be meaningful. It can be slow, steady, and quiet, shaping the context for everything else without ever calling attention to itself. The Milky Way is falling through space, not like a dropped object hurtling toward the ground, but in the same gentle, inevitable way that everything responds when gravity takes hold. This isn't the kind of falling we usually think about, where something plummets from point A to point B. This is more like a dance, a graceful movement through dimensions we can barely comprehend. When you throw a baseball straight up, it falls back down. That's gravity at work, in its simplest form. But if you could throw that baseball fast enough sideways, something interesting happens. As it falls toward Earth, the ground curves away beneath it. The baseball keeps missing the planet, falling around it instead of into it. That's an orbit, really. Falling sideways, forever chasing something it never quite catches. Our galaxy does something similar, but on a scale that makes baseballs and planets seem like grains of sand. The Milky Way moves forward through space, while simultaneously being pulled by countless gravitational influences. It's a cosmic glide that never comes to rest, shaped by forces we can't see, but definitely feel. People sometimes imagine there's one giant object out there, like a cosmic magnet, pulling our galaxy toward some specific destination. The reality is far more subtle and perhaps more beautiful. Gravity doesn't usually work that way. It comes from everywhere at once, the combined influence of all the matter scattered across vast regions of space. Some of that matter we can see, some we cannot. Around us, other galaxies float in patterns that aren't random at all. They trace out long filaments and dense clusters, with enormous empty regions stretched between them. Scientists call this the cosmic web, and it's shaped largely by something called dark matter. This invisible stuff makes up most of the universe's mass, but it doesn't give off light. You can't point a telescope at it and take a picture. Dark matter reveals itself through what it does. It bends the paths of galaxies, shapes how stars move within those galaxies, holds entire clusters of galaxies together. On the largest scales imaginable, it acts like a hidden framework, guiding how all the visible matter we can see gathers and flows. Our galaxy sits embedded in this framework. We're not floating freely in some empty void. We're part of a region where the distribution of mass creates what you might think of as a gravitational slope. Just like water flows downhill, galaxies tend to drift toward areas where there's more mass concentrated. This movement happens slowly, spread out over millions and billions of years. But over those vast timescales, it shapes how everything moves on the largest scales. There's a particularly intriguing feature in our cosmic neighborhood that astronomers call the Great Attractor. It's not a single object, more like a general area where a tremendous amount of mass seems to be gathered. Our galaxy, along with many others nearby, appears to be drifting in that direction. We're being drawn by a gentle but persistent pull. The Great Attractor lies behind a dense part of our own galaxy, which makes it difficult to study directly. The dust and stars in the Milky Way block much of our view, like trying to see through thick fog, but by watching how other galaxies move around us, astronomers can infer that something massive sits in that direction, shaping the flow of our entire local region of the universe. This falling, then, isn't about heading toward one specific destination. It's about responding to a landscape of gravity that stretches across distances our minds struggle to grasp. The Milky Way's path gets shaped by nearby galaxies, distant clusters, and that vast, unseen presence of dark matter all working together. But there's another layer to consider, one that adds even more complexity to this cosmic story. The universe itself is expanding, space is literally stretching, carrying distant galaxies away from each other as time passes. On very large scales, this expansion dominates everything, making galaxies recede from one another as if the fabric of reality was slowly inflating like a balloon. Within smaller regions, though, gravity can still overcome this expansion. Here, galaxies can still move toward each other, still fall together, still form systems that stay bound across cosmic time. Our Milky Way and the nearby Andromeda galaxy provide a perfect example. Despite the universe expanding all around us, these two galaxies are on a slow collision course, drawn together by their mutual gravitational attraction. When you think about our galaxy falling through space, you're really thinking about two broad tendencies working simultaneously. On larger scales, space itself stretches, encouraging everything to drift apart. On smaller but still enormous scales, gravity pulls matter together, creating the clusters and filaments and groups we observe. The Milky Way's motion results from finding balance between these influences, a kind of cosmic compromise written in the fundamental language of physics. This creates a gentle, ongoing flow. The galaxy doesn't move because it was launched by some ancient cosmic event and has been coasting ever since. It moves because it continuously responds to the gravitational environment surrounding it. Every nearby galaxy, every distant cluster, every concentration of dark matter adds its own tiny influence to the overall picture. If you could somehow step far enough away to see the Milky Way's motion in full context, you wouldn't see a straight line pointing towards some target. You'd see a curved, complex path shaped by how mass gets distributed across vast regions of space. It would look less like an arrow and more like a river winding through a broad, shallow valley, following contours carved by forces much larger than itself. Modern physics offers an even deeper way to think about this falling. Gravity isn't just a force that pulls things together across empty space. It's a reflection of how mass and energy actually shape the geometry of space and time itself. Massive objects create curvature in the fabric of the universe, and other objects follow the paths laid out by that curvature. From this perspective, the Milky Way isn't being pulled through space so much as it's following the shape of space itself. It moves along a path defined by how the universe curves in our particular region. Falling becomes a matter of following natural contours in a cosmic landscape we can barely perceive. Think about walking across a gently sloped field. You might not notice the slope at first, especially if it's very shallow and subtle, but if you let go of a ball, it will slowly roll in a particular direction, revealing the shape of the ground beneath your feet. The Milky Way is like that ball, and the field is the gravitational landscape created by the mass of the entire universe around us. In a way, this falling connects us to something profound about existence itself. We're not separate from the cosmos, not observers looking out at distant phenomena. We're participants, embedded in flows and currents that stretch across space and time. Every atom in our bodies, every breath we take, is part of this vast, graceful movement through dimensions we're only beginning to understand. Galaxies drift through space without any engines or fuel, moving in a way that feels almost effortless. They respond to invisible forces, flowing along paths carved by the universe itself. This motion emerges naturally from their surroundings, like water finding its way downhill. The Milky Way doesn't choose where to go, it simply follows the gravitational landscape around it. When we walk somewhere, we pick our direction, we decide which street to take. But galaxies experience direction differently. Their paths unfold based on where mass is distributed throughout the cosmos. Dense regions pull them one way, while empty spaces offer less resistance in other directions. The galaxy becomes part of a conversation between matter and space that's been going on for billions of years. This creates a fascinating contrast with how we usually think about movement. Our daily motions feel deliberate, intentional. We stand up because we choose to. We reach for things because we want them. The Milky Way's journey through space isn't like that at all. It's more like a river flowing through a valley, responding to the shape of the land around it. The same gravitational force that guides our galaxy also keeps your feet on the ground. When you feel that familiar tug pulling you downward, you're experiencing the exact same interaction that steers galaxies across vast distances. The strength is different, the scale is different, but the underlying principle remains identical. This creates an invisible thread connecting your everyday experience to the grandest motions in the universe. Our galaxy contains hundreds of billions of stars, each one potentially surrounded by planets. The sheer scale feels overwhelming when you really think about it. Yet even something this enormous is just one participant in a much larger cosmic dance. Massive structures spanning millions of light years influence the Milky Way's path, making our entire galaxy seem small by comparison. The motion we observe today carries echoes from the universe's earliest moments. When the cosmos was young, tiny irregularities in how matter was distributed got amplified over time. These ancient ripples eventually grew into galaxies, clusters, and the vast web-like structure we see throughout space today. The Milky Way's current trajectory preserves a memory of those primordial conditions, like a fossil record written in motion. This means that when you imagine our galaxy falling through space, you're also witnessing the continuation of a story that began shortly after the Big Bang. The path we're following connects us directly to those first moments when matter started clumping together. There's something almost poetic about how the present carries forward such ancient history. The speeds involved are truly staggering when measured in kilometers per second. But the changes that actually matter on human timescales happen incredibly slowly. The Milky Way won't suddenly veer off in a new direction tomorrow, or next year, or even in the next million years. Its motion reflects a balance of forces that evolve gradually over cosmic time. This slow, steady quality makes the whole process feel less dramatic and more like a background condition of existence. It's similar to how a tree grows, or how coastlines change shape over geological time. The motion is always there, always continuing, but it doesn't announce itself loudly. As our galaxy moves along its path, everything inside gets carried along for the ride. The Sun, all the planets, Earth, and everyone on it share exactly the same motion through space. There's no sense in which some parts of the galaxy are racing ahead, while others lag behind. We're all embedded in the same flow, experiencing it from our own tiny, local perspective. This shared journey creates a quiet kind of unity. You're not watching galactic motion from the outside like some detached observer. You're part of it, woven into the same gravitational currents that shape the Milky Way's path. Your motion through space is identical to the galaxy's motion, just viewed from a much smaller scale. The universe doesn't allow anything to exist in true isolation. Every piece of matter, from the smallest particles to the largest galaxy clusters, influences everything else through gravity. This creates an interconnected web where motion emerges from relationships, rather than individual choices. The Milky Way falls because it exists in a cosmos where everything responds to everything else. When you consider this cosmic choreography, It reveals something profound about the nature of existence itself. Motion becomes less about action and more about participation. Direction becomes less about choice and more about response to environment. The galaxy's journey through space transforms into something that feels almost meditative, a gentle drift guided by forces far greater than any individual component. This perspective can change how you think about your own place in the universe. You're not separate from these cosmic processes. You're an integral part of them. The same gravitational interactions that guide galaxies also flow through your daily experience, connecting the most mundane moments to the grandest scales of space and time. There exists something in our galaxy that shapes everything we see, yet remains completely invisible to us. When we gaze up at the night sky, we witness only a small fraction of what actually governs the cosmic dance above our heads. The stars that twinkle so brilliantly are merely the visible performers in a much larger, hidden orchestra. Scientists call this mysterious presence dark matter, and it represents one of the most profound puzzles in modern astronomy. Unlike the matter that makes up our bodies, our planet, and the stars we can see, dark matter doesn't emit light, doesn't absorb light, and doesn't interact with ordinary matter in any way we can directly observe. It reveals itself only through its gravitational influence, like a ghost that moves objects but never shows its face. The story of how we discovered dark matter begins with a simple observation about how things move in space. In our solar system, planets closer to the Sun orbit much faster than those farther away. Mercury races around the Sun in just 88 days, while distant Neptune takes 165 years to complete one orbit. This happens because gravity weakens with distance, so objects farther from the Sun feel less pull and move more slowly. Early astronomers expected galaxies to work the same way. Stars near the center should zip around quickly, while stars in the outer regions should crawl along at a leisurely pace. But when they actually measured the speeds of stars throughout the Milky Way and other galaxies, they discovered something startling. Stars in the outer reaches were moving just as fast as those much closer to the center. This presented a serious problem. Based on all the visible matter they could count, stars, gas, clouds, planets, these outer stars should have been moving so fast that they'd fly right out of the galaxy and into the empty void between galaxies. The fact that they remained bound to their home galaxy meant something else was holding them in place, something with tremendous gravitational pull that no one could see. Picture standing in a dark room with only a candle for light. You can see a small circle around you clearly, but you know the room extends far beyond that pool of illumination. If you walked forward and bumped into furniture in the darkness, you'd realize your visible world was just a tiny part of a much larger reality. This captures the situation astronomers found themselves in, realizing that the glowing matter they could observe was just a small component of something much more vast and hidden. The solution to this puzzle lies in imagining our galaxy embedded within an enormous, invisible halo of dark matter. This halo extends far beyond the visible disk of stars, sometimes reaching several times farther than the galaxy's bright edge. The mass contained in this ghostly sphere outweighs everything we can see, all the billions of stars, all the planets, all the glowing gas clouds combined. If we could somehow make dark matter visible, the Milky Way would look completely different. Instead of an elegant spiral disk floating in empty space, we'd see a vast, dim sphere surrounding and encompassing everything. The beautiful spiral arms and central bulge would appear as bright decorations on a much larger, darker framework. Our Sun, as it makes its slow journey around the galactic center, isn't just responding to the gravity of visible stars and the central black hole. It's also moving within this sea of dark matter, following gravitational currents we cannot directly perceive. The stability of our solar system's orbit, the very reason we've enjoyed billions of years of relatively consistent conditions, depends partly on this invisible scaffolding. There's something almost poetic about this arrangement. The stars that seem so dominant and important when we look up at night are actually minority players in the cosmic drama. Most of the mass that determines how our galaxy behaves, how it holds together, how it moves through space, consists of matter that never announces itself with light, the universe's true architective work and mathematical analysis. Scientists didn't accept the existence of dark matter lightly. The idea that most of the universe consists of something completely invisible seems almost too strange to believe. But evidence has accumulated from multiple independent sources, each pointing toward the same surprising conclusion. Beyond individual galaxies, astronomers study enormous clusters containing hundreds or thousands of galaxies bound together by gravity. When they measure how fast these galaxies move relative to each other within their clusters, they find the same pattern. The visible matter falls far short of providing enough gravitational pull to keep the cluster intact. Once again, invisible mass seems to supply the missing gravitational glue. Another compelling piece of evidence comes from gravitational lensing, a phenomenon predicted by Einstein's theory of relativity. Massive objects bend the fabric of space itself, and light follows these curves as it travels through the universe. When a galaxy cluster lies between us and a more distant light source, it acts like a giant cosmic lens, distorting and magnifying the light from behind it. These distortions create beautiful arcs, rings, and multiple images that astronomers can study to map exactly where mass is located within the cluster. When they do this careful mapping, they often discover that much of the mass sits in regions where very little visible matter exists. The gravitational lensing reveals the presence of dark matter directly, showing its distribution and density through space. Perhaps the most remarkable aspect of dark matter is how it challenges our everyday intuitions about reality. We're accustomed to thinking that what we can see represents most of what exists. In our daily lives, this assumption usually works well, but on cosmic scales, it fails completely. Roughly 85% of all matter in the universe consists of this dark component that interacts with ordinary matter only through gravity. This realization forces us to confront how limited our direct perception of the universe really is. The atoms that make up our bodies, our planet, and all the stars we can observe represent just a small fraction of the cosmic inventory. We exist as tiny islands of familiar matter in an ocean of the unknown. The search for dark matter represents one of the most active areas in modern physics and astronomy. Scientists have built incredibly sensitive detectors deep underground, hoping to catch dark matter particles as they pass through Earth. They've created computer simulations showing how dark matter might clump together to form the large-scale structure we observe in the universe. They've proposed various theoretical candidates for what dark matter particles might actually be. Yet despite decades of intensive research, dark matter remains profoundly mysterious. We know it's there because we can see its effects, but we still don't know what it actually is. This uncertainty reminds us that even with all our technological sophistication, the universe still holds secrets that dwarf our current understanding. The invisible pole that guides our galaxy's motion isn't a physical object we could ever visit or touch. Instead, it's a gravitational influence arising from the distribution of dark matter throughout our cosmic neighborhood. This unseen matter creates currents and flows that carry entire galaxies along paths determined by forces we're only beginning to comprehend. Dark matter makes up most of the mass in our universe, yet we can't actually see it directly. The galaxies we observe, with all their brilliant stars and glowing gas clouds, represent just a small fraction of what's really out there. Everything else exists in this mysterious, invisible form that scientists call dark matter. Think about it this way: the entire cosmic web, that vast network connecting galaxy clusters across billions of light years, is basically held together by something we can't detect with our eyes or telescopes. We only know it's there because of how it pulls on the things we can see. It's like watching leaves dance in the wind. You can't see the air itself, but you know it's moving because of what it does to everything else. The Milky Way doesn't just drift through empty space on its own. It's actually embedded in this enormous invisible structure that acts like scaffolding for the whole universe. Ordinary matter, the stuff that makes stars and planets and us, naturally falls into the gravitational wells created by dark matter concentrations. Picture it like water flowing into valleys you can't see, but the water shows you where those valleys must be. This invisible framework stretches across millions of light years, connecting our local group of galaxies to distant clusters and superclusters. When the Milky Way moves, It's responding not just to nearby galaxies like Andromeda, but to this much larger, hidden landscape of gravitational influence. The galaxy is basically following invisible highways laid down by dark matter. What's fascinating is how this all started. In the early universe, there were tiny variations in dark matter density, almost imperceptibly small differences from one region to another. Over billions of years, gravity amplified these small differences, pulling more and more matter into certain areas. The pattern of galaxies we see today basically grew out of these ancient, microscopic variations in something we still don't understand. Our galaxy sits inside what astronomers call a dark matter halo, this vast invisible cloud that extends far beyond the visible disk of stars. But this halo isn't isolated. It overlaps and interacts with the halos around neighboring galaxies. Together, they form part of an even larger structure that influences how entire groups of galaxies move through space. There's something almost poetic about this situation. The thing that has the biggest say in where our galaxy goes is completely invisible to us. All those stars you can see on a clear night, they're basically passengers riding along in a vehicle they can't see, following roads they can't detect. The cosmic forces that determine the Milky Way's path operate in a realm that's hidden from direct observation. Scientists are still trying to figure out what dark matter actually is. Some think it might be made of exotic particles that barely interact with ordinary matter. Others wonder if we need to revise our understanding of gravity itself. Deep underground laboratories, space telescopes, and powerful particle accelerators are all searching for clues, but so far, the results have been frustratingly subtle. Dark matter reveals itself mainly through its gravitational effects, like a cosmic puppeteer working behind an invisible curtain. This uncertainty doesn't make it less important. It actually adds this layer of mystery to everything we observe. We're essentially watching a cosmic dance, where most of the dancers are invisible. There's something profound about living in a universe where the most influential components operate quietly in the background. It challenges our usual way of thinking about knowledge and understanding. We tend to trust what we can see and measure directly, but dark matter reminds us that reality often works through hidden mechanisms. If you could somehow strip away all the visible matter from the Milky Way, all the stars and gas and dust, you'd still have this vast invisible structure left behind, a dark matter halo with its own shape and density variations. And if you let ordinary matter fall back into this invisible framework, a galaxy would likely form again in roughly the same place, following the gravitational blueprints laid down by dark matter. This suggests that our galaxy is built on a foundation we can't see. Its bright, familiar form is like a visible skin, stretched over a much larger, darker body. When you look up at the night sky and see that band of light from countless stars, you're actually seeing just the tip of something much more vast and mysterious. The forces that guide galactic motion operate on scales that are almost impossible to grasp. Millions of light years across, billions of years in duration, they provide this deep, steady background rhythm that continues regardless of what happens on any individual planet. Yet in a strange way, you're connected to this story. The atoms in your body were forged in stars that followed paths influenced by dark matter's gravitational pull. The timing and location of stellar formation, shaped by this invisible component, played a role in creating and distributing the elements that eventually became part of you.
So when we talk about the Milky Way following dark matter's influence, we're also talking about the deep background conditions that made your existence possible.
Future discoveries might reveal what dark matter is made of, how it behaves on the smallest scales, how it connects to other fundamental forces. These answers could transform our understanding of galactic structure, cosmic evolution, and our place in the universe. But for now, the mystery continues. The Milky Way keeps moving through its invisible landscape, guided by forces we can detect, but not directly observe. There's something almost meditative about this idea, that our entire galaxy is on a journey shaped by hidden currents in the cosmic ocean. Both grand and humble at the same time, reminding us that even on the largest scales, the universe still holds its secrets close. Picture our galaxy, not as a lone wanderer, but as part of something much more intimate. The Milky Way belongs to what we call the local group, a cosmic family of dozens of galaxies, all bound together by gravity's gentle threads. This changes everything about how we think of our place in space. When you look up at the night sky, you're seeing just one member of this galactic neighborhood. Around us, scattered across millions of light years, other galaxies drift alongside us through the cosmic dark. Some are massive spirals like our own, others are tiny dwarf galaxies containing just a few billion stars. The local group isn't crowded or chaotic. It's more like a loose gathering, spread across several million light years of space. Gravity acts as the quiet force that keeps this family together, preventing its members from being swept away by the universe's expansion. There's something almost comforting in knowing we're not alone out here. At the heart of this group sit two giants, our Milky Way and the Andromeda Galaxy. These are the heavyweights, the ones whose gravitational influence shapes everything around them. Dozens of smaller galaxies orbit these two dominant systems, like satellites circling their parent worlds. Many of these dwarf galaxies remained hidden from us for decades. They're so faint, so diffuse, that only careful surveys with modern telescopes revealed their presence. Some have been stretched and distorted by the gravitational pull of their larger neighbors, pulled into strange, irregular shapes that tell stories of cosmic interaction. If you could map the local group from the outside, it wouldn't look neat or organized. Instead, you'd see a scattered three-dimensional cloud with the Milky Way and Andromeda as the main anchors. The smaller galaxies would appear sprinkled around them in loose arrangements that shift and change over cosmic time. The distances involved here are staggering. Even our closest galactic neighbors sit tens of thousands of light years away. Andromeda, our largest companion, lies about 2.5 million light years distant. The light reaching your eyes from that galaxy tonight began its journey long before humans walked the Earth. Yet despite these immense separations, gravity still connects everything. It's a weak pull across such vast distances, but given millions and billions of years, even gentle forces reshape the paths of entire galaxies. This is patience on a cosmic scale, where change unfolds over timeframes that dwarf human history. The local group itself doesn't exist in isolation either. We're part of something even larger called the Virgo supercluster, a vast collection of galaxy groups and clusters spread across more than 100 million light years. Within this supercluster, our local group occupies a relatively quiet corner, far from the dense, crowded regions near the center. This positioning matters more than you might think. In the packed cores of galaxy clusters, galaxies pass close to each other regularly. They strip gas from one another, trigger massive bursts of star formation, sometimes even merge into larger systems. Here in our quieter neighborhood, encounters are rarer and gentler, unfolding over very long timescales. On even larger scales, the universe reveals its web-like structure. Galaxies and galaxy groups arrange themselves along filaments of matter, with enormous empty regions called voids stretching between them. Dark matter shapes this cosmic architecture, creating patterns that resemble foam or spiderwebs when viewed from the right perspective. The local group sits on one of these filaments, part of a long chain of matter stretching across vast distances. Along this chain, gravity gently guides galactic motion, drawing systems toward denser regions where filaments intersect and large clusters form. Our galaxy's path responds not just to nearby neighbors, but to this much larger cosmic geography. There's something profound about this layered structure. From Earth, the night sky looks like a simple scattering of stars. But behind that simple view lies a hierarchy of nested systems. Stars orbit within galaxies, galaxies move within groups, groups drift within superclusters, superclusters trace out the cosmic web. Each level connects to the next through gravity and motion. Within our local group, the Milky Way and Andromeda play particularly important roles. Their combined mass creates a gravitational center for the entire group. Many smaller galaxies orbit around one or the other, or follow paths influenced by both. The relationship between these two giants will determine much of our cosmic future. Right now, the Milky Way and Andromeda are approaching each other at about 100 kilometers per second. That sounds fast, but on galactic scales it's leisurely. The two will take billions of years to meet, but their approach is fast enough to shape both systems' long-term destiny. As they draw closer over time, their gravitational fields will interact more strongly. Stars in the outer regions of each galaxy will feel the pull of the other. Orbits will slowly stretch and shift. Gas clouds may be disturbed, potentially triggering new waves of star formation across both systems. This future encounter is often called a collision, but that word misleads us. The distances between individual stars are so vast that direct stellar impacts are extremely unlikely. Instead, gravitational forces will reshape both galaxies' overall structure, eventually blending them into a single, larger system, but that story lies far in the future. In the present, our local group's motion through the cosmic web follows more subtle patterns. Astronomers studying galactic velocities in our region find that many share a common drift, a bulk motion through space caused by gravitational influences from massive structures farther away. One of these influences comes from a region called the Great Attractor, a massive concentration of matter that appears to be drawing galaxies in our part of the universe toward it. The local group seems to be moving in that general direction as part of a broader flow of cosmic material. This gives us a vivid picture of riding through a cosmic ocean. The ocean, in this case, is the large-scale structure of the universe itself, a landscape of gravity shaped by matter and dark matter across hundreds of millions of light-years. Our local group becomes like a small flotilla, moving along the currents of that ocean. From our perspective, this motion remains almost impossible to notice directly. The night sky doesn't change from evening to evening in any obvious way. Galactic positions shift by tiny amounts over thousands of years, not hours or days. The scale is so large and the pace so slow that it blends into the background of human experience. Yet the motion is real and measurable. By observing light from distant galaxies and measuring how the universe's expansion stretches that light, astronomers can determine how fast those galaxies move away from us. Comparing these measurements in different directions reveals the subtle imprint of our local group's motion through space. This technique shows that the Milky Way and its neighbors move at hundreds of kilometers per second relative to the cosmic microwave background, the faint afterglow of the early universe that fills all of space. That background acts like a universal reference frame, defining what it means to be at rest on the largest scales. There's a quiet symmetry in this connection. Our galaxy group's motion today links through cause and effect to the universe's state shortly after it began. The paths galaxies trace continue early patterns of density and motion that existed in the first moments of cosmic history. This connection makes the local group's journey feel less like random wandering and more like a long unfolding story. The galaxies aren't drifting aimlessly. They're following paths shaped by the universe's initial conditions, amplified and refined by billions of years of gravitational interaction. Within this story, the Milky Way is one character among many. Its individual rotation, its future encounter with Andromeda, its place within the local group all fit into a broader narrative of structure formation and cosmic evolution. Nothing exists in complete isolation, even on these vast scales. This mirrors something familiar from everyday life. People are shaped by their communities, their environments, their connections to others. Individual paths are influenced by broader patterns, whether cultural, social, or historical. The galaxy's journey through the local group reflects that same idea, written on a much grander scale. There's also a sense of shared fate in riding the local group through space. The Milky Way's future is tied to its neighbors' futures. The eventual merger with Andromeda will reshape the entire group. Smaller galaxies will be drawn into the process, their stars and gas becoming part of a new, larger system. Over even longer timescales, the local group itself may interact with other groups and clusters, potentially becoming part of larger structures. Or as the universe's expansion continues, it may become increasingly isolated, with distant galaxies drifting beyond gravity's reach and fading from view. This long-term perspective feels both vast and strangely intimate. The sky you see now won't exist billions of years from now. The pattern of galaxies, the distribution of light in the universe, even the concept of a visible cosmic neighborhood will change as the universe evolves. But for the moment, the local group remains a small, bound family of galaxies moving together through the cosmic web. The Milky Way, carrying its hundreds of billions of stars and countless worlds, is one member of this family, riding the same gravitational currents as its companions. You're part of that ride too, in a very literal sense. The atoms in your body move through space as part of this larger system. The ground beneath you, the air around you, the planet itself, all share in the motion of the Milky Way and the local group. This doesn't mean you need to feel motion in everyday life. The movement is so smooth and so shared that it fades into the background of experience. But it can add a quiet layer of meaning to being here, now, in this moment. You're not just located in a room or city or country. You're located in a galaxy, in a group of galaxies, in a universe that's constantly evolving. This softens the boundaries between what feels close and what feels distant. The night sky, which can seem remote and unreachable, becomes part of the same system you inhabit. The galaxies you can barely see with naked eyes become distant neighbors, moving along with you in a shared, very slow journey. There's no need to imagine this journey, heading toward a final destination. Like the Milky Way's own rotation, it can be thought of as an ongoing process, a pattern of movement continuing as long as the universe exists. The local group rides the currents of the cosmic ocean, guided by mass distribution and space's expansion. Within that group, the Milky Way follows its own quiet, steady path. Within the Milky Way, the sun and planets trace their own loops, carrying you along with them. Each level of motion nests inside the next, like gentle waves within waves, stretching from the smallest scales of daily life to the largest scales of cosmic structure. The Milky Way isn't just moving on its own, it's riding along with its companions, part of a small family of galaxies drifting through a vast interconnected universe. When we gaze up at the night sky, we see stars that seem perfectly still, frozen in their ancient patterns. But this stillness is an illusion. Our entire galaxy, along with everything we've ever known, is actually racing through space at incredible speeds. We're passengers on a cosmic journey that began billions of years ago, and we didn't even know we were moving until very recently. The Milky Way galaxy, our cosmic home, is hurtling through the universe at hundreds of kilometers per second. That's fast enough to circle the Earth in just a few minutes. But here's the strange part. We're not moving randomly. We're following a path, as if something massive and invisible is gently pulling us forward. Scientists call this mysterious influence the Great Attractor, though the name makes it sound more dramatic than it actually is. Think about how we discovered this cosmic motion in the first place. When you're sitting in a moving train, you can tell you're moving by watching trees and buildings pass by your window. But in space, there's no obvious background to measure against. Everything you can see, every star and galaxy, is also moving in its own way. So astronomers had to get creative. They found their reference point in something most people have never heard of, the cosmic microwave background radiation. This radiation is like a faint glow that fills all of space, left over from when the universe was very young and incredibly hot. Back then, about 380,000 years after the Big Bang, the universe was so dense that light couldn't travel very far without bumping into something. As the universe expanded and cooled, this light was finally set free, and it's been traveling ever since. Today, we can detect this ancient light coming from every direction in the sky. Here's where it gets interesting. If you're moving through this sea of radiation, you'll see it slightly brighter in the direction you're heading and slightly dimmer behind you. It's similar to how the sound of an ambulance siren changes pitch as it approaches and then moves away from you. When scientists measured this effect for our galaxy, they discovered we're moving in a very specific direction through space. But we're not alone in this journey. The nearby galaxies that make up our local neighborhood, including the famous Andromeda galaxy, are all moving in roughly the same direction. It's as if we're all part of a massive convoy, drifting together through the cosmic ocean. This coordinated movement suggests that something with enormous gravitational pull is influencing our motion. The challenge is figuring out exactly what that something is. The region of space where this influence seems strongest lies hidden behind the thick disk of our own galaxy. When we look in that direction, we see a dense band of stars, gas, and dust that blocks our view of whatever lies beyond. It's like trying to see through a thick forest. The very thing we're part of prevents us from seeing what's on the other side. Astronomers have found clever ways around this cosmic blind spot. They use infrared light and radio waves, which can penetrate through the dust much better than ordinary visible light. Slowly, piece by piece, they've mapped what lies in that hidden region. What they found wasn't a single massive object, but something more complex and subtle. The Great Attractor isn't really a single thing you can point to and say, "There it is." Instead, it's a region of space where matter has gathered in unusually large concentrations. Galaxy clusters, each containing thousands of individual galaxies, are packed together more densely than normal. Mixed in with all this ordinary matter is an even larger amount of dark matter, the mysterious invisible substance that makes up most of the universe's mass. One particularly important structure in this region is called the Norma Cluster, a dense collection of galaxies that seems to be part of an even larger system. Rather than being pulled toward a single point, our galaxy is more like a marble rolling down a very gentle, very wide slope. The slope is created by the combined gravitational influence of all this matter spread across hundreds of millions of light years. This broader perspective reveals something remarkable about the universe. On the largest scales, matter isn't randomly scattered. Instead, it forms an intricate web of filaments and nodes, with galaxies strung along these cosmic highways like cities connected by interstate roads. The Great Attractor is part of this larger architecture, a major intersection in the cosmic web. Our galaxy belongs to what scientists call the Laniakea supercluster, a vast region of space containing over 100,000 galaxies, all bound together by gravity. The name Laniakea comes from Hawaiian words meaning immeasurable heaven, which seems fitting for something so enormous that light takes 520 million years to cross from one side to the other. Within this supercluster, galaxies flow along specific paths, converging toward regions where matter is most concentrated. Our Milky Way is riding one of these flows, following a route that was laid down in the very early universe. Shortly after the Big Bang, tiny variations in the density of matter, differences smaller than 1 part in 100,000, eventually grew under gravity's influence to become the massive structures we see today. There's something profound about realizing that our galaxy's current path was determined by events that happened when the universe was less than 1 million years old. We're following a course set by quantum fluctuations from the universe's infancy, cosmic ripples that have been growing and evolving for nearly 14 billion years. In a sense, the Great Attractor is like a memory encoded in the structure of space itself. This motion affects more than just our galaxy. When astronomers measure the velocities of nearby galaxies, they find something curious. These galaxies aren't just moving away from us due to the expansion of the universe, which is what we'd expect. They also have an additional sideways motion, a shared drift in the direction of the Great Attractor. It's as if the entire local region of space is sliding together across the cosmic landscape. The analogy of marbles in a tilted bowl captures this well. If you have a wide, shallow bowl filled with marbles and gently tilt it, all the marbles will start rolling in the same general direction. They might bump into each other and follow slightly different paths, but the overall flow is determined by the shape of the bowl. The Great Attractor is like that tilt, not dragging us toward a specific point, but creating a gentle slope that guides our motion across a vast region. This helps explain why the term "can't escape" might seem misleading at first. We're not trapped like objects falling into a black hole. Instead, we're part of a gravitational environment that shapes our motion in a more gentle way. As long as we remain within this region of space, our path will continue to follow these large-scale patterns. It's not about being unable to escape, it's about being part of a cosmic neighborhood, with its own internal dynamics. But there's another player in this cosmic story, one that adds an interesting twist to our understanding. The universe isn't just shaped by gravity. There's also a mysterious force called dark energy that's causing the expansion of space itself to accelerate. This means that on the very largest scales, the universe is growing faster and faster, pushing distant regions apart with increasing speed. Within our local supercluster, gravity still wins this cosmic tug-of-war. The Milky Way and our neighboring galaxies remain bound together by their mutual attraction. But beyond the boundaries of our supercluster, dark energy takes over. Galaxies in distant regions are being carried away by the expansion of space, their light growing redder and fainter as the distance between us increases. This creates a strange situation. We're part of a vast gravitational family that includes hundreds of thousands of galaxies, all moving together through space. But this family is becoming increasingly isolated from the rest of the universe. Over billions of years, the galaxies outside our supercluster will be carried so far away that they'll eventually disappear from view entirely. Future astronomers, living trillions of years from now, might see a universe that appears to contain only the galaxies in their local group. This long-term evolution adds a contemplative note to our cosmic journey. The structures we're part of today, including the Great Attractor itself, aren't permanent features of the universe. They're temporary arrangements of matter and energy that exist for a while and then slowly change as the universe continues to expand and evolve. Our galaxy's path isn't a straight line towards some eternal destination. It's a response to conditions that are themselves constantly shifting. In many ways, this mirrors patterns we see in our own lives. We move through landscapes of influence that we can't always see clearly. Family, culture, economic conditions, historical events, all these create currents that guide our paths in ways we might only understand much later. We respond to forces we can't always perceive, following routes shaped by circumstances beyond our immediate control. The scale of galactic motion operates over distances and times that dwarf human experience. The forces involved work across hundreds of millions of light years and billions of years, yet there's something oddly comforting about being part of this grand cosmic flow. While we go about our daily lives, dealing with immediate concerns and local challenges, we're also passengers on one of the most remarkable journeys imaginable. Our galaxy drifts through space like a luminous island carried by invisible currents. The Great Attractor, rather than being a threatening presence, is simply part of the terrain that shapes these currents. It's a feature of the cosmic landscape that helps determine which way the river flows. We're not being pulled towards some dramatic fate. We're participating in an ancient pattern of motion that connects us to the deepest structures of the universe itself. There's a quiet beauty in this realization. The same physical laws that govern a falling apple or the orbit of the moon also guide our galaxy's path through space. Gravity works the same way at every scale, creating order and pattern from the smallest objects to the largest structures in the cosmos. We're part of that pattern, riding along on a journey that began with the universe itself, and will continue long after our sun has faded to a cold ember. As you consider this cosmic perspective, remember that it doesn't diminish the importance of smaller scales. Your personal experiences, your relationships, your daily routines, all of these remain as meaningful as ever, but they now exist within a broader context, part of a story that stretches from quantum fluctuations in the early universe to the eventual fate of galaxies billions of years in the future. In the quiet moments before sleep, there's something peaceful about knowing we're all traveling together through this vast, mysterious, and beautiful cosmos. When you think about galactic movement, it helps to imagine something entirely different from the crashes and collisions we know. Two enormous star systems have been slowly approaching each other for eons, their paths guided by invisible forces across distances that make our planet seem like a speck of dust. The Milky Way and Andromeda galaxies are engaged in what you might call a cosmic dance, one that began long before Earth even had solid ground. This meeting isn't happening like a car accident or two waves smashing together. The space between individual stars is so vast, so empty, that even when entire galaxies pass through each other, the stars themselves rarely touch. Instead, gravity does all the work, slowly reshaping both systems over billions of years. It's like watching clay being molded by invisible hands. Except the clay is made of hundreds of billions of stars. Right now, as you listen to this, Andromeda sits about 2.5 million light-years away. That means the light reaching your eyes tonight, if you could see it, left those distant stars when our earliest ancestors were just learning to use tools. Entire species have come and gone in that time. Ice ages have carved and recarved the Earth's surface. Mountains have risen and worn away to dust. Yet on the scale of galaxies, this distance is almost neighborly. Andromeda is racing toward us at roughly 100 kilometers per second. That sounds incredibly fast, but across such enormous distances, it translates to a journey lasting about 4 billion years. The interesting thing is, both galaxies already feel each other's gravitational pull. The process has already begun, even though its most dramatic moments lie in the unimaginably distant future. Most people don't realize that what we see of a galaxy, all those bright stars, represents only a tiny fraction of its actual mass. The bulk of each galaxy exists in something called a dark matter halo, an invisible sphere of material that surrounds the visible parts. These dark matter halos will be the first to overlap as the galaxies approach, and when they do, they'll start changing how both systems move through space. Tidal forces will begin to stretch and distort the spiral arms of both galaxies. You've experienced tidal forces yourself every time you've seen ocean tides caused by the moon's gravity. On a galactic scale, these same forces can pull entire streams of stars out into space, creating long ribbons of light that arc and curve through the darkness. Some stars get flung into wide, looping orbits. Others get drawn closer to the galactic centers. The neat spiral shapes we see today will gradually become warped, irregular, stretched out. Gas clouds within both galaxies will get compressed and disturbed, triggering bursts of new star formation. Quiet regions that have remained dark for millions of years will suddenly light up with clusters of young, brilliant blue and white stars. This happens in waves, different parts of each galaxy lighting up at different times, creating a slow, pulsing effect that can last for hundreds of millions of years. At the centers of both galaxies sit supermassive black holes, objects so dense that nothing, not even light, can escape once it gets too close. As the galaxies interact, some of the stirred-up gas and stars will be driven inward, feeding these black holes and causing them to grow. Sometimes this makes them incredibly active, shooting out powerful beams of radiation that can briefly outshine entire galaxies. After one or more close passes, the Milky Way and Andromeda will settle into a single, combined system. Scientists sometimes playfully call this future galaxy Milka or Andra Milky. It won't be a spiral anymore. Most simulations suggest it'll become a large elliptical galaxy, a smooth, rounded cloud of stars moving in many different directions rather than spinning in a flat disk. For any planets still existing at that time, including whatever might remain of Earth, the experience will be both subtle and dramatic. The night sky will transform in ways that are hard to imagine. Andromeda, currently just a faint smudge, barely visible to the naked eye, will grow larger and brighter over millions of years. Eventually it will stretch from horizon to horizon, a vast glowing shape dominating the sky. The familiar constellations will slowly distort as the background stars shift. New patterns will emerge while old ones fade away. The Milky Way's own band of light across the sky will become more complex and tangled as streams of stars from both galaxies weave together. Yet for any individual living being, these changes will unfold so slowly that they'll barely be noticeable from one lifetime to the next. The sun is expected to still be shining when this cosmic encounter reaches its peak, though it'll be older and brighter than it is today. Simulations suggest our solar system's orbit will likely be altered by the gravitational reshaping. We might end up flung into a more distant, elongated path, perhaps much farther from the center of the merged galaxy than we are now. This doesn't necessarily spell disaster. The distances between stars are so enormous that even in the chaos of a galactic merger, direct encounters remain rare. The main changes will be in the broader environment, the shape of the galaxy, how stars and gas are distributed, and of course the view of the sky. There's a quiet irony in these timescales. 4 billion years feels impossibly long from a human perspective, but in cosmic terms, it's just another chapter in an ongoing story. Galaxies have been merging and reshaping each other since the universe was young. Our Milky Way itself is the product of many past mergers with smaller galaxies. Their stars now form part of our galaxy's outer halo and thick disk. This upcoming encounter with Andromeda is simply the next step in that same process. The universe continues building bigger, more complex structures out of whatever material it has available. Instead of seeing the Milky Way as permanent and unchanging, you can think of it as a long-lived but evolving system, something that will eventually become quite different from what it is today. The merger represents both an ending and a beginning. In one sense, it's the end of the Milky Way and Andromeda as separate entities. But it's also the birth of a new galaxy, with its own structure, its own patterns of movement, its own future. The stars that now belong to one galaxy or the other will become part of a shared system. New stars will be born in the aftermath. The combined galaxy will take its place in the cosmic web as a larger, more massive node, influencing the motion of smaller galaxies around it. There's something oddly comforting about this continuity. Even as specific forms change, the overall process continues. Matter moves, gathers, reshapes itself, then moves again. The universe doesn't hold on to any single arrangement forever, but it also doesn't erase what came before. Instead, it transforms everything. You are part of a galaxy that will one day become something else entirely. The atoms in your body belong to a planet that will one day change beyond recognition. The world you know participates in a larger story that doesn't stop with any single chapter. Yet none of this needs to feel urgent or overwhelming. The timescales stretch so far beyond human experience that they exist outside any reasonable sense of hurry. The meeting of these two galaxies isn't something to prepare for or worry about. It's simply part of the long, slow rhythm of the cosmos. Meanwhile, the galaxies continue their approach, one tiny step at a time. The distance between them shrinks by an imperceptible amount each year. The outer regions feel each other's presence more strongly. The path of each system bends almost invisibly in response to the other. This slow bending of paths reminds us that motion in space rarely involves straight lines and sudden changes. Instead, it's about curves, gradual shifts, gentle adjustments guided by gravity and the way mass spreads across the universe. Big changes often begin long before you can see their effects. Small shifts accumulate over time. Paths bend gradually, and only when you look back across long periods do you see how much has actually changed. The early stages of this galactic encounter are already underway, even though the most dramatic scenes lie in the distant future. Both galaxies are already influencing each other, already part of the same unfolding story, participants in a transformation that will reshape this corner of the universe in ways both beautiful and profound. Stars move through space like wandering travelers, each following its own path across the cosmos. The constellations we recognize today, those familiar patterns etched in our imagination, are really just temporary meetings of distant suns. Each star drifts at its own pace, slowly pulling away from its neighbors over thousands of years. This movement, called proper motion, reshapes the sky so gradually that entire civilizations rise and fall without noticing the change. If we could step back 10,000 years, we'd see the same star patterns that slightly stretched, like someone had gently tugged at the corners of the night. Go forward another 10,000 years, and those shifts become more obvious. Over hundreds of thousands of years, our familiar constellations would dissolve completely, replaced by arrangements no human eye has ever seen. The Big Dipper would lose its shape, Orion would scatter, and entirely new patterns would emerge from the slow dance of stellar motion. This quiet reshuffling makes you wonder about the stories we tell ourselves. Every culture has looked up and seen heroes, animals, gods, written in starlight. But those stories are written in disappearing ink, slowly fading as the stars themselves migrate to new positions. Future civilizations will create their own myths, from completely different patterns, finding their own meaning in arrangements we can't even imagine. Meanwhile, something much more dramatic approaches our galaxy. The Andromeda Galaxy, that faint smudge barely visible in dark skies, creeps closer every moment. Right now it's over 2 million light-years away, but gravity pulls it steadily toward us. In about 4 billion years, these two massive spiral galaxies will begin their cosmic collision. The word collision sounds violent, but galactic mergers unfold like slow-motion poetry. Andromeda will first appear larger in our sky, its spiral arms becoming distinct instead of that barely noticeable blur. Over millions of years, it will grow into an unmistakable presence, no longer something you have to search for, but a glowing companion stretching across significant portions of the night. As the galaxies interpenetrate, streams of stars will be pulled from both systems. The familiar band of the Milky Way will become complex and layered, crossed by ribbons of light from Andromeda's stars. Instead of our current single river of starlight, the sky will display overlapping structures, arcs and streams creating a rich, almost crowded feeling. Any observers during this period would witness a night sky far brighter and more detailed than ours. After the merger settles, the combined galaxy will take on a rounder, more elliptical shape. The spiral arms that define both galaxies today will fade into a smoother, more uniform glow. This future sky will lack the sharp band of the Milky Way, we know, instead offering a broad, diffuse brightness in many directions. It will be a different kind of beauty, gentler perhaps, but still profound in its own way. This transformation reflects something deeper about change itself. The universe doesn't preserve our familiar landmarks forever. What seems permanent and eternal from our brief perspective is actually just one frame in an incredibly long movie. The night sky, we know, represents just one moment in an ongoing story of cosmic evolution. But an even more fundamental change affects the entire universe. Space itself expands, and this expansion appears to be accelerating. Dark energy, that mysterious force we barely understand, drives galaxies apart at ever-increasing rates. This expansion works subtly on small scales but dramatically across vast distances. Over billions of years, distant galaxies will be carried farther away from us. Their light will stretch to longer wavelengths, becoming redder and fainter until many slip beyond any practical observation. The universe will appear to shrink around any future observers, not because anything moves inward, but because the observable horizon moves outward faster than light can travel. In the very distant future, perhaps tens of billions of years from now, the night sky will look much emptier than it does today. Currently, you can see a few nearby galaxies with the naked eye and countless more with telescopes. But as expansion continues, those distant systems will gradually fade from view. Eventually, the only visible galaxy will be the merged remnant of our own local group. The grand cosmic web of clusters and filaments that astronomers study today will have drifted beyond the observable horizon. Future astronomers will inhabit what appears to be a much smaller, lonelier universe. They'll see one large galaxy, surrounded by dark, mostly empty space. The cosmos will feel more like an island than the rich, interconnected structure we observe now. This creates an odd kind of perspective. We live during a special time when the universe is still young enough that its large-scale structure remains visible. We can look out and see other galaxies, clusters, even the faint afterglow of the Big Bang itself. That window won't remain open forever. In some sense, we're witnessing the universe during its most transparent, most revealing era. On more local scales, the future night sky will also be shaped by stellar evolution. Even after the Milky Way and Andromeda merge, they won't form new stars forever. Star formation requires gas, and over time, much of the available gas gets used up or blown away by stellar winds and supernovae. As billions of years pass, the rate of new star birth will slow dramatically. The sky will gradually become dominated by older stars. These cooler, longer-lived suns will replace the bright blue giants that currently mark regions of active star formation. The overall glow of the galaxy will soften, shifting toward warmer, redder tones. Many of the brightest stars in today's sky will be long gone, having burned their fuel quickly and ended their lives in spectacular explosions. These stellar deaths leave behind neutron stars and black holes, dark remnants that no longer shine on their own, but still carry mass and influence nearby objects. Over time, the sky will accumulate more and more of these invisible influences, objects that shape the motion of visible stars without contributing any light themselves. Our own sun won't be part of these distant skies. In about 5 billion years, it will exhaust the hydrogen fuel in its core and begin to change. It will swell into red giant, potentially engulfing the inner planets, including Earth. Eventually, it will shed its outer layers and leave behind a small, dense white dwarf, a hot ember slowly cooling over trillions of years. For any future observers, the sun will no longer be a bright central presence, but just another faint point of light among countless others. This transition from main sequence star to white dwarf represents one of the most common stellar fates, and future skies will be filled with these slowly cooling remnants. As time stretches even further into the future, beyond the lifespan of most current stars, the night sky will continue its transformation. The longest-lived stars, small red dwarfs, can burn for trillions of years. They'll become the main sources of light in the universe, shining quietly, long after larger stars have faded away. Eventually, even these persistent stars will begin to die out. The sky will grow progressively darker, populated mostly by white dwarfs, neutron stars, and black holes. The universe will enter what cosmologists call the degenerate era, a time when the familiar processes of star formation and stellar evolution have largely ended. The night sky of this era will be almost unimaginably different from what we see now. Light will become rare and precious, appearing only as brief flares in a vast dim landscape. Yet even in this deep future, motion and change won't completely stop. Black holes will continue to interact and merge, and they'll slowly evaporate over incredibly long timescales through Hawking radiation. These vast timescales challenge our usual sense of permanence and change. What we consider eternal, like the patterns of stars or even the existence of galaxies, represents just brief episodes in cosmic history. The night sky serves as a kind of cosmic clock, marking different eras in the universe's evolution through its changing appearance. There's something both humbling and comforting about this perspective. When you look up at a star tonight, you're seeing a moment in a story that began long before you existed and will continue long after. The future sky isn't something separate from the present sky. It's the same system evolving according to the fundamental laws of physics. This connects to deeper questions about continuity and change. The atoms that make up stars, planets, and people are recycled through generations of cosmic evolution. They're forged in stellar cores, scattered by explosions, gathered into new systems, and used again. The future night sky will be made partly of the same elements that compose the present one, just arranged in different configurations. So when you observe the night sky, you're witnessing not just a static view but an ongoing process. The light reaching your eyes participates in a long exchange of energy and matter that links past, present, and future. This softens the stark division between now and then, suggesting instead a continuous transformation where each moment emerges naturally from the previous one. The night sky has always served as a mirror for human imagination and curiosity. People have looked up and found stories, navigation aids, calendars, and inspiration for art and philosophy. In the far future, if there are still beings who look up and wonder, they'll encounter a different sky but may experience that same impulse to find meaning in what they observe. The patterns will change, the stories will evolve, but the fundamental act of looking up and questioning might remain constant. This suggests something persistent about consciousness and wonder that transcends the particular arrangements of matter and energy that happen to exist at any given time. From your current position, you're experiencing a brief moment in this long cosmic timeline. The sky, you know, belongs neither to the distant past nor the distant future, but represents a unique arrangement shaped by the current stage of universal evolution. This can bring a quiet sense of presence to the moment, an awareness that this particular view exists now and will never exist again, in quite the same way. The universe carries us along in ways we rarely pause to consider. Your body right now, settled and quiet, travels through space at speeds that would seem impossible if you could somehow step outside and watch. The Milky Way spins around its center, dragging our entire solar system along in a journey that takes over 200 million years to complete just once. Yet here you are, feeling perfectly still. This contradiction reveals something profound about how we experience reality. Our senses evolved to notice immediate dangers and opportunities, not the grand choreography of cosmic motion. When you sit in a smoothly moving train, your body feels at rest until the brakes engage, or the track curves. The galaxy's movement is so vast, so steady, that it creates no turbulence your nervous system can detect. Every atom in your body participates in multiple dances simultaneously. Your heart beats roughly once per second. Earth completes its rotation every 24 hours. Our planet orbits the Sun annually. The solar system traces its path around the galactic center over countless millennia. Each rhythm nested within larger rhythms, like musical harmonies playing at different scales of time and space. Consider how the same physical forces that govern your breath also shape the architecture of galaxies. Gravity pulls air into your lungs with each inhalation, the same fundamental force that binds billions of stars into the spiral arms we call home. Electromagnetic interactions hold the molecules in your cells together, identical to the forces that ignite stellar fusion across the cosmos. The distinction lies not in different laws of physics, but in the scale at which these laws express themselves. Scientists estimate our local group of galaxies drifts towards something called the Great Attractor, a gravitational anomaly, pulling on matter across hundreds of millions of light years. This cosmic current flows at over 600 kilometers per second, yet produces no sensation of movement for anyone riding along. Your morning coffee sits undisturbed on the table, completely unaware of its participation in this immense journey. The contrast between human stillness and galactic motion touches something deeper than physics alone. When you choose to be still, you exercise a kind of agency that the universe itself seems to lack. Stars follow gravitational laws without deciding their paths. Galaxies merge because mathematics demands it, not because they prefer company. Your moment of rest, however brief, represents something genuinely different, a conscious pause within the unconscious flow. Ancient astronomers noticed that stars maintain their relative positions night after night, year after year. They called them fixed stars, distinguishing them from the wandering planets that traced complicated paths across the sky. We now know those apparently fixed points of light race through space at tremendous velocities, their positions changing constantly when measured with sufficient precision. The illusion of stillness emerges from perspective and timescale. Human civilization spans perhaps 10,000 years if we count from the earliest agriculture. The Sun has completed less than 1/20th of a single galactic orbit during our entire recorded history. Entire empires rise and fall within what amounts to a brief moment of cosmic time. This perspective can feel either humbling or liberating, depending on how you approach it. Your personal timeline intersects with geological epochs, stellar life cycles, galactic evolution. The calcium in your bones formed inside dying stars billions of years ago. The water in your cells may have spent eons frozen in comets before eventually joining Earth's hydrosphere. You exist as a temporary rearrangement of very old materials, conscious matter contemplating its own cosmic heritage. The observable universe contains roughly 2 trillion galaxies, each hosting billions of stars, many surrounded by planetary systems we can barely begin to catalogue. Within this vast population, the Milky Way follows its own trajectory through space, influenced by the gravitational pull of neighboring galaxy clusters, stretching across distances measured in millions of light years. Dark matter, invisible to our instruments, but detectable through its gravitational effects, outweighs all visible matter by roughly 5 to 1. This hidden scaffolding shapes galactic structure and motion in ways astronomers are still working to understand. You rest within a cosmos dominated by mysterious components that reveal themselves only through their influence on things we can see. The cosmic microwave background radiation, afterglow of the Big Bang itself, bathes every point in space with photons that have traveled for nearly 14 billion years. These ancient messengers pass through your body constantly, carrying information about the universe when it was less than 400,000 years old, far too young to host galaxies or stars or planets or life. Local galactic motion includes our eventual collision with the Andromeda Galaxy, predicted to occur in roughly 4.5 billion years. Computer simulations suggest this merger will reshape both galaxies, flinging some star systems into intergalactic space while drawing others into new orbital configurations. The timescale makes such predictions feel more like mythology than astronomy. Meanwhile, quantum mechanics describes constant activity at the smallest scales. Virtual particles pop in and out of existence within the vacuum of space. Electrons tunnel through barriers that classical physics says should be impenetrable. Atoms vibrate with thermal energy, even at temperatures approaching absolute zero. 1000, absolute zero. The stillness you feel emerges from statistical averaging across countless microscopic movements. Your brain processes roughly 11 million bits of sensory information each second, but conscious awareness handles only about 40 bits during the same interval. Most cosmic motion falls into the category of background information your nervous system filters out as irrelevant to immediate survival. Evolution optimized us to notice changes that might affect our next meal or our safety over the coming hours, not astronomical phenomena unfolding over geological time. The expansion of space itself carries distant galaxies away from us at velocities that increase with distance. Objects sufficiently far away recede faster than light can travel, disappearing beyond an ever-shrinking cosmic horizon. The universe grows larger and emptier as time passes, its content spreading across volumes that boggle comprehension. Yet here in this moment, you can experience genuine stillness within the context of all this motion, not as an escape from cosmic reality, but as a conscious participation in it. Your awareness represents something remarkable, matter organized in such a way that it can contemplate its own place within the larger story of existence. The Milky Way galaxy drifts through space at incredible speeds, carrying our entire solar system along for the ride. We're moving at about 230 kilometers per second around the galactic center, plus another 600 kilometers per second through the broader universe. That's fast enough to circle the Earth in just under 3 minutes. Yet from our perspective here on this small planet, we feel perfectly still. This disconnect between cosmic motion and human perception reveals something fascinating about how direction works in the universe. On Earth, we navigate using fixed reference points. The sun rises in the east, sets in the west. We have magnetic north, geographic landmarks, GPS coordinates. Everything seems anchored, stable, knowable, but step back to the galactic scale, and those certainties dissolve. There is no cosmic North Star, no universal GPS system. The Milky Way moves relative to other galaxies, which themselves move relative to larger structures, called galaxy clusters. Everything is in motion, relative to everything else. Astronomers measure our galaxy's movement against something called the cosmic microwave background, the afterglow of the Big Bang. Relative to this ancient light, we're racing toward a region of space in the direction of the constellation Leo, but that's just one way to measure cosmic direction. Relative to our nearest major neighbor, the Andromeda Galaxy, we're actually moving closer. In about 4 billion years, these two massive spiral galaxies will collide and merge. From Andromeda's perspective, we're the ones approaching. Neither viewpoint is more correct than the other. This relativity of motion puzzled early astronomers. Galileo realized that you can't tell if you're moving or standing still without looking at something else for reference. If you're on a perfectly smooth train, moving at constant speed, physics experiments inside that train work, exactly the same as if the train were stopped. The same principle applies to our cosmic journey. We don't feel the Earth spinning at 1,000 miles per hour at the equator. We don't sense our orbital dance around the Sun at 67,000 miles per hour. The solar system's motion around the galactic center at over 500,000 miles per hour goes completely unnoticed. Our bodies evolved to detect changes in motion, not constant motion. The fluid in our inner ear responds to acceleration, not steady movement. This biological reality shaped how we experience direction and space. When you're walking, your brain constantly updates a mental map of your surroundings. Neurons called place cells fire when you're in specific locations. Grid cells create a coordinate system in your mind. Head direction cells work like an internal compass. This neural GPS system operates even in complete darkness. But this sophisticated navigation system evolved for earthly distances and speeds. It breaks down at cosmic scales. Your brain can't intuitively grasp the vast distances between stars, let alone galaxies. A light year, the distance light travels in a year, equals about 6 trillion miles. The nearest star beyond our Sun sits over 4 light years away. The Milky Way spans roughly 100,000 light years from edge to edge. If you could shrink it to the size of a dinner plate, our entire solar system would be smaller than a grain of sand. Earth would be invisible, lost in the microscopic realm. Within this vast cosmic dance, our galaxy follows invisible currents shaped by gravity. Dark matter, which outweighs normal matter 5 to 1, creates the scaffolding that guides galactic motion. We can't see dark matter directly, but its gravitational effects sculpt the universe's large-scale structure. Think of galaxies as leaves floating on a river. The water carries them along predetermined channels, around obstacles, toward distant destinations. Individual leaves don't choose their path. The current decides. Our Milky Way flows along filaments in something called the cosmic web. Matter isn't distributed randomly through space. Instead, it forms an intricate network of dense filaments, separated by vast empty voids. Galaxies slide along these cosmic highways, like traffic on an interstate system. The local group, our small collection of nearby galaxies, moves as a unit through this cosmic web. We're all falling toward a massive concentration of galaxies called the Virgo cluster. Beyond that lies an even larger structure, the Great Attractor, pulling thousands of galaxies across hundreds of millions of light years. But here's the strange part. The Great Attractor itself appears to be moving towards something even more massive, a structure so large astronomers call it the Shapley supercluster. Layer upon layer of cosmic motion, each following the gravitational pull of increasingly vast collections of matter. This creates a cosmic paradox. From a human perspective, direction implies purpose, intention, goals. We walk toward destinations. We plan routes. We navigate with purpose. But the universe itself has no destination, no plan, no ultimate goal it's trying to reach. Galaxies don't wake up and decide which way to go. They follow the contours of space-time, bent and shaped by mass and energy. Einstein showed us that massive objects warp the fabric of space itself. Galaxies roll along these curves like marbles on a stretched rubber sheet. The expansion of space itself adds another layer of complexity. The universe is getting bigger, carrying galaxies apart from each other. But this isn't expansion into empty space, like a balloon inflating. Space itself is stretching, creating more distance between distant objects. This cosmic expansion means that the most distant galaxies we can observe are racing away from us faster than the speed of light. Not because they're moving through space that quickly, but because space itself is expanding between us and them. The light from these galaxies is stretched to longer, redder wavelengths as it travels across expanding space. From this perspective, asking which direction the Milky Way is heading becomes almost meaningless. Direction only makes sense relative to something else, but in an expanding universe, those reference points are constantly changing their relationships to each other. Perhaps the most profound realization is that the universe has no center, no edge, no preferred direction. Every point in space can consider itself the center of the observable universe. From any galaxy's perspective, all other galaxies appear to be moving away, carried by cosmic expansion. This cosmic democracy extends to motion itself. There's no absolute frame of reference, no universal standard of rest. Motion only has meaning in relation to something else. You're sitting still relative to your chair, moving with the Earth's rotation relative to the Sun, racing around the galactic center relative to the Milky Way's core. The ancient question of whether Earth or the Sun sits at the center of the solar system missed this deeper point. Neither the Earth nor the Sun holds a special position in any absolute sense. They're both participants in a cosmic dance that has no fixed center, no ultimate reference point. This relativity of motion connects to something profound about consciousness itself. When you're deeply focused, absorbed in an activity, your sense of direction feels sharp, meaningful. You know where you're going, what you're doing, how to get there. That in moments of rest, reflection, or transition toward sleep, that directional certainty can soften. The boundaries between here and there become less important. The urgency of forward progress fades. You exist more in the present moment, less in the anticipated future. This shift mirrors something about cosmic motion itself. Purposeless, yet purposeful. Directed yet without ultimate destination. There's something profound about the very air you breathe right now, something that connects you to the deepest workings of the cosmos. Every atom of oxygen that fills your lungs was forged billions of years ago, deep inside the nuclear furnace of a dying star. Think about that for a moment. The breath you just took contains particles that have been wandering through space for eons, drifting through cosmic dust clouds, swirling around nebulae, before finally making their way into your body. Your bones tell an even more remarkable story. The calcium that gives them strength came from stellar explosions so violent they outshone entire galaxies. The iron flowing through your bloodstream right now was created when massive stars collapsed in on themselves, generating temperatures hot enough to fuse lighter elements into heavier ones. You are literally made of star stuff, carrying within your very cells the remnants of cosmic events that happened long before Earth even existed. But here's where it gets really interesting. None of this stellar material stayed put after those ancient explosions. It all went traveling, carried along by the galaxy's rotation, swept up in vast streams of matter that flow between the spiral arms. The Milky Way isn't just sitting there like some cosmic landmark. It's spinning, turning completely around once every 250 million years. Our entire solar system rides this galactic carousel, moving through space at over 500,000 miles per hour. When you look up at the night sky, you're seeing other passengers on this same cosmic journey. Every star visible to the naked eye belongs to our local neighborhood of the galaxy. They're all swept along by the same rotational forces, all following their own orbital paths around the galactic center. Some stars move a bit faster, some a bit slower, creating a kind of stellar traffic pattern that astronomers call differential rotation. The most fascinating part is how this motion affects our view of the universe. Right now, we're positioned about halfway out from the galactic center, in what astronomers call the galactic habitable zone. This isn't just a lucky coincidence. Our location gives us a relatively clear view of the cosmos beyond our galaxy, unobstructed by the dense star fields and dust clouds that crowd the galactic center. If Earth had formed closer to the core, the night sky would be so bright with starlight that we might never have discovered other galaxies. The spiral arms themselves are not fixed structures, but rather waves of compression that sweep around the galaxy like ripples in a pond. Stars and gas clouds get squeezed as they pass through these density waves, triggering bursts of new star formation. Our solar system has probably crossed through several spiral arms during its 4.5 billion year history, each passage exposing Earth to different levels of cosmic radiation and potentially influencing the evolution of life. This galactic motion creates a kind of cosmic weather system. As our solar system orbits the galactic center, it bobs up and down relative to the galactic plane, like a horse on a carousel. This vertical motion takes us through different regions of space, some more dense with gas and dust, others relatively empty. These changes in our cosmic environment might have subtle effects on Earth's climate over very long timescales. The dark matter that holds our galaxy together remains one of the most mysterious components of this cosmic dance. It outweighs all the visible matter in the galaxy by at least 5 to 1, yet we can only detect it through its gravitational effects. This invisible scaffolding shapes how the galaxy rotates, creating the smooth velocity curves that first revealed dark matter's existence. Without it, the outer regions of the galaxy would spin so slowly that the spiral arms would wind up completely within just a few rotations. Our galaxy isn't traveling alone through the universe. It belongs to a small group of about 50 galaxies called the Local Group, dominated by the Milky Way and the larger Andromeda galaxy. This entire group is moving together through space, pulled by the gravitational influence of even larger structures. We're falling toward the Virgo cluster, a collection of over 1,000 galaxies located about 50 million light-years away. But the motion doesn't stop there. The Virgo cluster itself is part of an even larger structure called the Laniakea supercluster, containing over 100,000 galaxies spread across 500 million light-years of space. All of this matter streams together toward a mysterious gravitational attractor that astronomers call the Great Attractor, though its exact nature remains unclear due to its position behind the obscuring dust of our own galaxy. The expansion of the universe adds another layer to this cosmic motion. Space itself is stretching, carrying distant galaxies away from us at speeds that increase with distance. This means that while we're gravitationally bound to our local group of galaxies, we're becoming increasingly isolated from the rest of the universe. Billions of years from now, observers in our galaxy will see a much emptier cosmos, with most other galaxies having receded beyond the observable horizon. This cosmic perspective reveals something profound about the nature of permanence and change. Nothing in the universe stays exactly where it is. Even the most massive structures are in constant motion, following the gravitational choreography established by dark matter and dark energy. The very concept of a fixed reference point becomes meaningless on these scales. Your sense of place in the universe has to account for this universal motion. You're not located at some specific cosmic address that will always be the same. Instead, you're participating in multiple layers of movement simultaneously. Earth spins on its axis while orbiting the Sun, which orbits the galactic center, while the galaxy moves through the local group, which drifts through the larger cosmic web. These nested motions create a kind of cosmic rhythm that connects the smallest scales to the largest. The rotation of our planet gives us day and night, while its orbit around the Sun creates the seasons. The solar system's orbit around the galaxy takes 250 million years, long enough for continents to drift across Earth's surface and for major evolutionary transitions to occur. The galaxy's motion through the universe operates on even longer timescales, billions of years that span multiple generations of stars. There's something almost musical about these overlapping cycles, each with its own tempo and period. The fastest motions, like Earth's daily rotation, create the steady beat of our everyday experience. Slower motions, like our orbital journey around the Sun, provide the longer rhythms of seasonal change. The slowest motions, operating over cosmic time, create the deep bass notes of galactic evolution. This perspective can fundamentally change how you think about stability and security. What feels solid and permanent, from a human perspective, is actually part of vast, slow changes operating on timescales that dwarf human experience. The ground beneath your feet is moving through space at tremendous speeds, yet it feels perfectly still because you're moving along with it. The atoms in your body are immigrants from distant parts of the galaxy, temporary visitors that will eventually return to the cosmic recycling system when you die. The oxygen you breathe might once have been part of a star that died before our sun was born. The carbon in your cells could have spent millions of years drifting through interstellar space before becoming part of Earth's atmosphere and eventually finding its way into your body. This atomic recycling connects you to the deep history of the galaxy in ways that go far beyond mere metaphor. You are genuinely made from the processed remains of ancient stars, carrying their nuclear legacy in every cell. The elements that make you possible were created in stellar cores operating under conditions of almost unimaginable temperature and pressure, then scattered across space by explosive deaths that briefly outshone billions of ordinary stars. These stellar explosions, called supernovae, serve as the galaxy's distribution system for heavy elements. Without them, the universe would consist only of hydrogen and helium, the light elements created in the Big Bang. No carbon, no oxygen, no silicon, no iron, no rocky planets, no water, no chemistry complex enough to support life. Every supernova enriches the galaxy's supply of heavy elements, making more complex structures possible. The timing of these explosions follows the galaxy's star formation history. Early in the Milky Way's history, when gas was abundant and star formation rates were high, supernovae occurred much more frequently than they do today. This early period of intense stellar recycling built up the galaxy's inventory of heavy elements, making solar systems like ours possible. We live in a galaxy that has been seasoned by billions of years of stellar cooking. Everything in our galaxy moves together in ways we rarely stop to consider. The stars scattered across the Milky Way, they don't communicate with each other, they don't form relationships like we do. But they're all bound by the same gravitational forces, all part of the same slowly rotating system. This creates a kind of cosmic togetherness that exists without any awareness or intention behind it. When we think about our place in all this, something interesting emerges. The gravity keeping you connected to Earth right now, it's part of the same fundamental force shaping our entire galaxy. The atoms making up your body, they follow identical physical laws as atoms in stars, thousands of light years away. Time itself flows the same way for you as it does for distant solar systems. We're physically connected to everything around us, whether we realize it or not. Stars form different orbital patterns as they move through space. Some galaxies collide and merge, creating entirely new structures. On our human scale, people make choices that lead their lives in unexpected directions. But underneath all these individual differences, there's something deeper happening. A shared movement forward that includes everything from the smallest particles to the largest galactic clusters. Our galaxy doesn't have a final destination marked on some cosmic map. Instead, it's heading toward an eventual meeting with the Andromeda Galaxy. This collision will reshape both galaxies into something completely new. After that, star formation will gradually slow down, and our galaxy will become quieter, redder, older. The universe will keep expanding, pushing distant regions further and further apart. These aren't steps towards some ultimate goal. They're just stages in an ongoing process. This changes how we might think about moving forward in our own lives. Usually when we say forward, we mean progress towards something better. In cosmic terms, forward simply means later, the next state of whatever system we're looking at. The universe doesn't measure its own success or failure. It just responds to conditions, creates new conditions, and responds to those. Cause leads to effect, effect becomes cause. There's something gentle about placing your daily experiences within this broader context. Your life, like the galaxy's changes, unfolds as a sequence rather than following a straight line towards some predetermined end. Moments connect to other moments. Choices create new situations. Relationships evolve in ways you can't always predict. You don't need to know exactly where a path leads when you take the first step. Time itself becomes softer when you think about it this way. Instead of time pushing you forward like some external force, you can experience it as something you move with. Minutes and hours aren't acting on you from the outside. They're part of the same flow you're part of. The present moment stops feeling like a point you're rushing past and becomes more like a space you can actually inhabit. Our galaxy exists fully in each moment of its existence. It doesn't skip ahead to some future configuration of stars and gas and dark matter. Even though that configuration slowly changes, it's completely present to what it is right now. We can approach our own lives the same way, existing fully in this moment, while knowing it will transform into something else. Perspective shifts everything here. From an enormous distance, the Milky Way looks like a single faint spiral among countless others. Move closer, and it becomes a complex system of stars and clouds and invisible fields. From inside it, like where we are, it becomes the night sky itself, the background of every world it contains. Your life works similarly. From far away, it might seem like a brief event in a much longer history. From within your own experience, it contains everything that matters to you. We can hold both perspectives simultaneously without cancelling either one out. You can care deeply about the details of your immediate experience while staying aware that those details exist within an infinitely larger story. Neither view negates the other, they just operate at different scales. Every person, animal, tree, rock, and cloud of interstellar gas participates in the same overall motion through space and time. You're not separate from the rest of the universe, you're included in it. This doesn't mean the universe watches over you personally or guides your individual choices. It means you and the universe share the same physical reality, the same fundamental processes. When isolation or uncertainty feels overwhelming, remembering this connection can provide a different kind of stability. Not because it makes problems disappear, but because it places them in a wider context. The galaxy's motion doesn't solve human concerns or answer personal questions, but it does offer background continuity, a sense that larger patterns keep unfolding, regardless of what happens in any single life. The universe carries memory within its structure. How galaxies are distributed reflects conditions from the very early universe. The composition of stars tells us about previous generations of stellar life and death. Heavy elements exist because of ancient explosions that scattered them across space. Your own life carries memory too, in experiences and knowledge and stories that shape how you interpret what comes next. When you look up at stars, you're seeing light that left its source years or centuries or millennia ago. You're literally looking into the past. The night sky you observe isn't exactly how those stars appear right now. It's how they appeared when their light began traveling toward your eyes. The present moment already includes layers of different times, all arriving at your awareness simultaneously. This means you carry the past with you, not just as memory, but as an active ingredient in the present moment. Your current experiences include influences from everything that came before: your relationships, your learning, your previous choices. You're not starting fresh each time you move forward. You're carrying a personal history that helps shape what happens next. Actions you take now become part of the conditions influencing future moments. In small ways, you contribute to what comes next, just like the galaxy's current state helps determine its future configuration. This doesn't mean every action carries cosmic significance, but every action does have some effect within the local system you're part of. You're connected to chains of cause and effect, without being responsible for entire chains. Scientists can predict some aspects of our galaxy's future path with reasonable confidence. It will continue moving within our local group of galaxies, eventually merge with Andromeda, then drift within whatever larger structures remain gravitationally bound in the distant future. But other aspects remain genuinely uncertain. The nature of dark energy, the ultimate fate of cosmic expansion, the long-term behavior of matter and energy on the largest scales, these are still open questions. This uncertainty doesn't stop the galaxy from continuing along its path. It doesn't pause and wait for complete answers before moving forward. You can approach your own life similarly. You don't need everything figured out before taking next steps. You can keep responding to what's directly in front of you, adjusting as new information and experiences arrive. There's a kind of trust in this process. Not necessarily trust in specific outcomes, but trust in the ability to navigate change as it unfolds. The universe provides a distant example of this. It has moved through enormous transformations over its history, from an extremely hot, dense state to a vast, structured cosmos filled with galaxies and stars. It accomplished this without any plan, driven by simple physical laws and the unfolding of initial conditions. Even right now, as you rest here, you're being carried by multiple layers of motion you can't directly feel. Earth rotates, orbits the sun. The sun orbits the galactic center. Our galaxy moves through the local group. The local group moves within the cosmic web. Your senses register immediate surroundings, textures, sounds, nearby light. These vast motions are too smooth and widely shared to register directly. But you can know about them, hold them lightly in awareness. This creates quiet depth in ordinary moments. The room around you isn't just a room, it's a small part of a planet that's part of a solar system, that's part of a galaxy, that's part of a universe. This layering doesn't need to feel overwhelming. It can simply exist like a wide background behind more immediate details of your experience. You may not travel with the same people throughout your entire life. Relationships change, people come and go, but you're always traveling with something. You travel with the ground beneath you, the air you breathe, the light reaching your eyes. You travel with the planet, the solar system, the galaxy. In this sense, you're never completely alone in your movement through time and space. Sometimes feeling out of place means feeling disconnected from immediate surroundings or the people nearby. Remembering your belonging to this moving universe offers a different frame. Even when you feel out of place in particular situations, you remain in place in the broader sense of participating in the universe's ongoing processes. The galaxy's motion unfolds slowly. Its changes happen over millions and billions of years. Nothing occurs quickly on that scale. Human life can feel much faster by comparison. Days fill up, weeks pass. Years seem to accelerate when you look back on them. Holding these different timescales side by side invites gentleness toward your own pace. You don't have to move as fast as everything around you might suggest. The universe itself isn't hurried. Scientists continue studying our galaxy's motion, structure, and future. New observations refine previous models. New questions keep emerging. Your own path forward also remains not fully known. You can make plans and predictions, but there will always be elements of surprise. This shared openness to the future connects human experience with cosmic evolution. Both involve moving into unknown territory, guided by current understanding, but remaining open to what hasn't yet appeared. You don't need to frame this as adventure or challenge. It can simply be a fact. The future isn't completely written for galaxies or for people. The unknown shifts from something to fear into something to hold lightly. The galaxy will go wherever gravity, mass, and expansion carry it. You will go wherever choices, circumstances, and time carry you. Both journeys unfold within the same universe, at different scales, with different kinds of awareness. The Milky Way continues its slow rotation, its gradual drift, its long changes. You continue your own movement through moments and days and years. These paths intersect in this instant, in this awareness. There's room for rest, for curiosity, for connection, and for whatever emerges next without needing to define it beforehand. The story doesn't require a final conclusion. It can remain open, like a horizon you're moving toward without needing to see exactly what lies beyond it. you.